Hello everyone, a very good morning to all of you, and can you quickly confirm if the audio and video is clear? Hello. A very good morning, and can you quickly confirm if the audio and video is clear? Okay. Okay, so a very good morning to all of you, and welcome to the next session for your AFM exam oriented portfolio batch. So when we are looking at yesterday's class, we'll do a quick recap and then we'll progress further into today's session. So yesterday we discussed about the basics of portfolio, then we went into the calculation of return, where we said that the single security return can be calculated as a capital appreciation, that is P1 minus P0, plus a cash flow, that is dividend, for example, divided by P0 into 100. This is the base for a single security return, which you do on an annual basis. Alternatively, you can even do it on a multi-year basis for the holding period on an annualized basis as well. The more tricky part is the calculation of risk. Now, the source for risk is the uncertainty, that is a volatility, and that can be calculated among various measures like range, but the most important measure is the standard deviation, which is calculated as under the root summation of x minus x bar the whole squared upon n. Again, the rationale for doing this squaring and square rooting is to cut out the negative and the positive, which are offsetting each other, and as a result we try to find the total of the deviations. This is if there is no probabilities. If there is probabilities, instead of dividing it by n, you will multiply it by p for finding the standard deviation. Next, we went into the calculation of portfolio return, where we said that the portfolio return is a weighted average return where the amounts invested are taken as the weights. Amounts invested at the beginning of the period are to be taken as the weights. So if it is a 1 year investment, amounts at the start of the year will be taken as the weights. If it's a multi-year investment, then the amounts at the beginning of each of the respective year will be taken as weights. Based on which we tried a few questions, and we actually went into question number 4, and we had to try the standard deviation calculation. Tell me, did you get a chance to calculate the standard deviation? Did you have any problems in that? Okay. So we'll discuss that once. In this particular case, you had to calculate the return for 2005-6, then 6-7, and then we had to find the standard deviation. Now, standard deviation can be calculated either based on historical data, but there is only one 2005-6 historical, or it can be calculated based on expected data. Now, in expected, you have a range, that is, you have 220, 250, 280. So you can calculate this based on the prices, or you can calculate it based on the percentage return. We prefer to calculate based on the percentage return. So what we will do is, at each of these levels, we will calculate the return. Like if the price was 220 minus 220 plus 20, that is a 9.09% return. For M, similarly a 22.73% return, and similarly a 36.36% return. Now there are 3 observations, but each of these observations have a different probability, like 0.2, 0.5 and 0.3. So they have different probabilities, and thereby you will calculate the standard deviation. So over here you will have the standard deviation of let's say M, where you will first find the M bar. M bar over here will be 9.09 into 0.2, 22.73 into 0.5, 36.36 into 0.2, that is around 24.09%. The deviation from 24.09, well, M minus M bar the whole squared into P over here. So you will find M minus M bar the whole squared into the probabilities, and that way you will find around 91.09. You should have calculated this for a practice. Otherwise, portfolio as a chapter has a bit of calculations, unlike other chapters where there will be more of, let us say, analysis. Here there is more of calculation, so you should, when I tell you to calculate, ensure that you kind of spend some time to calculate so that it cements your concepts. If you have not done it yesterday, at least after class today, ensure that you get it done. Okay, fair enough. The chapter wise weightage for AFM, yes, we'll do that. Just remind me again, but broadly in AFM you have 4 or 5 A category chapters like derivatives, foreign exchange, valuation, portfolio, which will almost certainly come for around 10 to 15 marks. Then but I'll just come back to it, so you can just remind me in some time by the end of class. So over here you'll have 91.09 and hence you get 9.54%. And for standard deviation of n, you can do it in a similar way. You'll get 4.83. Now, according to you, what is more risky? A company with a 9 standard deviation or a 4 standard deviation? What do you guys think? On an analytical level, they are asking you comment on the comparative advice X of the comparative risk in the two investments by calculating standard deviation in each case. So they're requiring you to comment on the comparative risk by calculating standard deviation. I hope you did the standard deviation calculation. If not, ensure that you do it today. For M, it came to around 9.54. For N, it will come to around 4.83. What do you guys think? What is more risky? Higher the standard deviation, more the risk. That is right. So over here, between the two, M is going to be more risky. Based on the standard deviations only, M has a higher risk, as it has a higher deviation compared to N. So it's not derivation, it is deviation. So it has a higher deviation as compared to N. Are we clear with this? Okay, so that takes care of your basic standard deviation calculation. And if you're able to solve this, I would say in yesterday's class, whatever was done, you are in a fairly good position. So next we go on into portfolio risk. Now we discussed portfolio return yesterday. Now we are going into portfolio risk. Now generally I would say this is one of the most important areas in this chapter. Like there will be CAPM, capital asset pricing model, where you have beta and you have the portfolio risk. So this is extremely important. So we'll take our own sweet time and we'll first understand what it means, why, and all the concepts. Okay, so let's get started. Fasten your seat belts and let's go into this. So you have the portfolio risk. Like before you go to portfolio risk, if I were to find the portfolio return for two securities, let us say you call them A and B, then this is a weight of A into the return of A plus the weight of B into the return of B. So basically your portfolio return will be the weighted average return. Now by that logic, your portfolio risk should also be the weighted average risk. Well, by that logic, if you look at the portfolio risk, your portfolio risk should also be the weight of A into maybe the standard deviation of A plus the weight of B into the standard deviation of B. Done, finish. So what is the difficult part in this? Well, the thing over here is this will not equal to the weighted average. And before we go into the formula, we need to understand why is it not the weighted average, because the return is a weighted average return. So why is it not the weighted average? Let's take an example of any two stocks. Let's say there's Tata Steel Limited, which is a steel manufacturer, and there is Maruti Suzuki Limited, which makes cars, and one of the core inputs of a car is a steel. You need a lot of steel in making the car. So let us say the current market price, or CMP, current market price P0 for Tata Steel is 100. Let's say current market price of Maruti is also 100. So over here, let's say you have one share of each. So if I go to see your portfolio per se, your portfolio is worth 200 rupees. Now, during the course of the year, what happens is the steel price goes up significantly. And hence by the end of the year, Tata Steel is in a good position because it is now able to sell steel at a higher price. Like what is happening in today's environment, if I give a practical perspective to oil, you see the oil prices are going up significantly. So those companies which are exploring oil, who are kind of digging out someone like a British Petroleum, etc., you will see their prices going up significantly because they're going to get a lot more collection on their oil. Whereas those entities which are consuming oil greatly, like You look at an Indigo who is going to consume oil, or you look at a lot of these oil distribution companies, you will see that their prices are falling. So at a higher steel price, let's say Tata Steel does extremely well and its price goes up to 150, so there is a deviation, maybe around a 50 deviation, standard deviation. I'm just keeping it simple because there's just two observations. So from 100 it deviates to 150. But at the same time, Maruti faces the pinch of the higher steel prices, and hence the price of Maruti falls, let us say, to 50. So if I go to see simplistically, okay, I'm not going into the exact numerical calculations, it is more for your concept based understanding. If I look at the deviation, I can see there is a 50 deviation in Tata Steel. There's also a 50 deviation in Maruti. Now, please answer in the chat, okay? Can the standard deviation be negative? Like return can be positive or negative. We have discussed this earlier yesterday also. It can be a positive or negative return. Can a standard deviation come as a negative answer? Okay. Why no? Why should standard deviation be positive only? Well, it is largely because the way standard deviation is calculated is x minus x bar the whole squared divided by n and then square rooted, which means your deviation maybe you're deviating 150 minus 100, so that's a 50 positive deviation, or you're deviating 50 minus 100, that's a 50 negative deviation. Ultimately, even for Maruti, if I do 50 minus 100 the whole squared and then divide by whatever is the observations, that is 50 minus 100, that's a negative 50 squared, that is 2500 positive, and then you again square root it. Well, it comes back to 50 positive. So that's absolutely right, because it is squared and square rooted. Your standard deviation mathematically cannot be negative, and that is the root cause of all of these problems. So if I look at the standard deviation of Tata Steel, I will do 150 minus 100 squared, square rooted, again comes back to 50. Let's say there is one observation only. If I look at Maruti, again I say that there is a negative 50, but negative 50 squared will become again positive 2500. Your standard deviation, let's say, comes to 50 positive. Squaring and rooting, that's absolutely right. That's good mathematical principles you have studied well in school. So over here, when we look at the standard deviations, we will see that if I look at the standard deviation of Tata Steel and Maruti, ideally that would be the weight of Tata Steel into the standard deviation of Tata Steel plus the weight of Maruti into the standard deviation of Maruti. Now, the weight of Tata Steel is the amount initially invested, that is 100. Weight of Maruti is also 100. Let's say there is one share for each of them. So that's a 50% weight into the standard deviation of 50. Maruti also a 50% weight into the standard deviation of 50. Now, if I multiply and find the answer, my final answer of standard deviation, let us say, comes to 50. Now, what does this actually mean? Well, this actually means that we are saying that the portfolio standard deviation is, let us say, 50. However, if I find the portfolio value at the end of the year, well, the portfolio value is 200. There is actually a zero deviation in the portfolio. So to say that it is a weighted average is actually wrong. It is not correct. It is not equal to the weighted average values. Are we first able to understand logically why portfolio standard deviation should not be weighted average, like portfolio risk was weighted average? Or yes or no? Okay, so this is the first thing. Sir, why are we discussing this? Because eventually you will study portfolio beta, you have portfolio return, everything will be weighted average. We first need to know that why can't we take portfolio standard deviation to be weighted average? Logically, it cannot be, because the deviation can be positive also, the deviation can be negative also, but mathematically the way standard deviation is calculated, it will always assume a positive deviation. It will always assume that 50 of Tata Steel is deviating, 50 of Maruti is also deviating in the same direction. That is 50 of Tata Steel ka deviation and Maruti ka 50 standard deviation is in the same direction, which may not necessarily be the case. Like here, Tata Steel is deviating 50 at the higher side, Maruti is deviating 50 at the lower side, and hence there needs to be something called as covariance. We need to calculate a term which measures the covariance. So have you heard about covariance earlier? We'll do how to calculate it, but variance calculates in a way the deviation of Tata Steel, variance calculates in a way the deviation of Maruti. But when I look at the covariance, I want to find how have they deviated if they were in a combination. So we'll go into covariance, but the base for going into that is the fact that Tata Steel and Maruti both may deviate in response to a particular event, like for example, a change in steel prices. But their deviation can be in the same direction, their deviation can be in a different direction, we don't know. So we want to find the strength of their relationship, whether it is a positive, whether it's a negative. That is why we go to covariance. Now, before we go to covariance and correlation, I will just give you the formula that you need to remember, and you will try to see if there is some similarity with what you have studied in the past. At the end of it, all this 40-45 minutes that we are going to discuss, this total, even if you just remember the formulas at the end, you'll be able to easily solve, but that is not our end goal. We want to understand it in a slightly better way. So we'll see what is to be done. So I'll give you the formula first. Standard deviation of AB will be calculated as, this is the formula, and you'll try to tell me if you have seen this relationship somewhere else. Weight squared A into the standard deviation squared A plus weight squared B into the standard deviation squared B plus 2 into weight of A, standard deviation A, weight of B, standard deviation B, into, that is the new part, into the correlation, we call it as R, correlation of AB. Now if I keep aside the correlation term, is this term appearing to be similar to something? I mean, keep aside the correlation term that I'm multiplying at the end, but is it appearing similar to something that we have done earlier? Well, this is A plus B the whole squared formula. If you remember, there is A plus B the whole squared. How do you get this? Well, A plus B the whole squared is actually A squared plus B squared plus 2AB. Sir, where are you taking us back to our school days? Yes, in across your AFM, you'll study a lot of things like regression, correlation, standard deviation, covariance, everything that you thought earlier that what is the use of teaching us all of this at an earlier level. Now you will use that in practice, okay? So looks like A plus B the whole squared, that is exactly correct. So over here, what we're trying to do is, well, we said standard deviation AB. Let's say if I were to square it, then ideally this should be weight of A into standard deviation of A plus the weight of B into the standard deviation of B. Well, the whole squared, ultimately I'll square root it, yes, but this should ideally be, if I square root it on both sides, this will become standard deviation of AB on the left hand side, and then this bracket if you open. So if you open this bracket, this is weight squared A into standard deviation squared A. Remember, this is pure Tata Steel standard deviation. Listen to the logic very carefully. This is pure Tata Steel standard deviation. I'm saying that, well, my portfolio has Tata Steel and Tata Steel is deviating, let's say, by 50, and it is 50% of my portfolio, plus weight squared B into the standard deviation squared of B. This is pure Maruti Suzuki standard deviation. My portfolio is Maruti Suzuki, it is moving by 50, so that will impact my portfolio. When I go to the last term, this is, in a way, if I rearrange, this is weight of A, weight of B, standard deviation A, and standard deviation of B. This is the third term. So ideally, I mean, I'm just rearranging these terms. Ideally, this is the term where A and B are commingling. They are moving together. This is pure A movement. This is pure B movement. However, the third term captures what is called as co-movement. In the first term, I don't need to adjust. It is pure A's movement. Second term, I don't need to adjust pure B's movement. But in the third term, when I take the co-movement, in a way, I am doing standard deviation of Tata Steel is 50. Standard deviation of Maruti is, I'm taking also 50. However, this 50 and 50 is assumed to be a positive 50 and positive 50, which may not be the case. Like I can clearly see over here that this 50, when it moves positively, at the same time this is moving negatively, and as a result, between the two, the co-movement maybe is a negative co-movement, and hence I need to calculate correlation. Well, are you slightly able to understand? See, ultimately we'll remember the formula, but my objective is you should understand also the base for what you are doing and why you are doing. First of all, why not this weighted average? Well, as you can see clearly, it is not giving you the right answer. When there is a zero co-movement, the portfolio of 200 remains as 200. It's still showing 50. Sir, why? Because you are assuming standard deviation to be a positive number. That is, you're assuming when Tata Steel moves by positive 50, Maruti will also move by positive 50. That is not correct. So we are saying that, okay, we will try to take the formula. In that, we'll bring in the co-movement term. Co-movement term is a correlation. How? If Tata Steel and Maruti were to be seen together in response to a particular event, how do they move? Well, they're moving in opposite directions. Yes, they're moving 50. First term A squared. They're moving 50. Yes, second term B squared. But when they're moving in an opposite direction, at least in our case. In which case, I need to bring in co-movement or correlation, and that needs to be only multiplied to the third term, because the third term takes standard deviation of A and standard deviation of B together. In the first term, it is only standard deviation of A. In the second term, there's only standard deviation of B. But in the third term, you kind of take them together, and hence you get a term called as correlation. How do you calculate what its logic? We will see. But that is why you have to multiply the correlation with the third term. Are we able to understand this? Okay, so over here you will multiply this third term with the correlation of AB, because when I do standard deviation of A into standard deviation of B and both of these numbers are positive, it's an implicit assumption that both of them are positively correlated, which may not be necessarily the case. Okay, so this is your formula, but in this formula we know how to calculate weights. Well, amount invested at the beginning. Yes, we have more. We will do three security, four security portfolios as well. Beyond that, in practice, you will have an Excel sheet, you will have financial models, and hence, if you fundamentally know what is to be done with two securities, three securities, you will also know what is to be done with 30 securities. Yes, you will not sit and manually calculate it, because in today's environment, you don't need to do that. So the institute also asks you questions maximum for 2 or 3 securities, but we'll also take it further for your understanding. There are multiple securities in your portfolio, and there'll be very good rationale that will come, let's say, in some time. So just hold on, keep your seatbelts tight. Okay, so over here when we are looking at correlation, so we know how to calculate weight of A. We hopefully know how to calculate the standard deviation of A. Similarly, weight of B, standard deviation of B. So all of these terms we know how to calculate, except for this one term, which we have conveniently forgotten. It is a long time back that we have done correlation. So we try to calculate the correlation. Now the formula for correlation is covariance of AB upon standard deviation of A into standard deviation of B. Okay, so sir, do I have to by heart this formula? No, not necessarily. We'll understand the logic. But again, over here, I know how to calculate the standard deviation of A. I know how to calculate standard deviation of B, but I don't know how to calculate covariance. Now, do you know how to calculate variance of A? Sir, what is variance of A? Variance is a square of standard deviation. So this is variance of A. This is A minus A bar the whole square divided by N. Do you agree with that? Okay. Similarly, variance of B, if you have to calculate, how do you calculate it? Well, this is summation of B minus B bar the whole square divided by N. This is the variance of B. Okay, so if I were to open this, what is this, sir? This is nothing but A minus A bar into A minus A bar upon N. This is summation of B minus B bar into B minus B bar upon N. So when I look at variance of A, or if I look at a variance of B, this is my core formula. Now, if I look at covariance, now what does covariance of A comma B? Well, covariance says that here when I'm multiplying A into A bar and into A minus A bar, so I'm finding the variance of A, that is deviation of A minus A bar, and also multiplying by A minus A bar only. Now, if I want to bring in B as well, all you have to do is, instead of taking A minus A bar into A minus A bar, So this will give you the variance of A. I don't want the variance of A. I want covariance. That is, if A and B were, if you can imagine, bundled together and they were asked to deviate. Okay, I'm bundling A and B together. Deviate. How much is A deviating from A bar and how much is B deviating from B bar? That is your covariance. So instead of A minus A bar into A minus A bar, I will just do A minus A bar into B minus B bar. Divide this by N. Are we able to understand? The word covariance means that it is not just variance of a single security, it is a variance of two securities. And hence, ideally for a single security, variance is A minus A bar into A minus A bar. Here, I remove the second A minus A bar term and instead bring in another term, that is B minus B bar. Okay, so we need a break right now. But okay, so let's not get too technical. Okay, is this going a little too heavy for you? So let's say we just remember covariance as A minus A bar into, let us say, B minus B bar upon N, and hence this will give me the covariance term. Basically, instead of A minus A bar in the formula, you remove that and bring B minus B bar. So this will give you the covariance. Now, this term is kept as a covariance term only. This term is kept as a covariance term only, which means, do I square root this? See, usually when you square root variance, you get standard deviation. However, there is nothing called as co-standard deviation. There is something called as covariance. So over here, when you look at covariance, we will keep it as this. A very, very, very common mistake that students end up doing in the main exam is they will end up square rooting this. They say, okay, when I do A minus A bar the whole squared, I will square root it. I'll do B minus B bar the whole squared, I'll square root this. They will end up square rooting the covariance as well, which is wrong. Covariance, as you have heard since your early school days or college days, is left as covariance only. There is nothing called as co-standard deviation, which means you do not square root it. Technically, you can square root it, but then that number is meaningless. Do not square root. It's a very, very common mistake that students, if you have a slightly shallow understanding, you might end up, oh, everything is being square rooted, chalo, I will square root this also. You will know it is covariance, which means it will be left as A minus A bar into B minus B bar divided by N. Now, what is the beauty of covariance? Think and tell me, can variance be negative? Can your variance of A or a variance of B be negative? Please answer. Like Tata Steel was 150 minus 100 into 150 minus 100. Okay, so this is 50 into 50 positive. Even if I look at Maruti, this was 50 minus 100 into 50 minus 100. That is minus 50 into minus 50, still positive. The beauty of covariance is, can your covariance be negative? Well, your covariance will have, let's say, summation of A minus A bar, which can be technically, if I go to see, just a second. So if I look at the covariance of A and B, there are two beauties to this. First is I will do A minus A bar, which is, let us say, 150 minus 100 into B minus B bar, that is 50 minus 100, which means technically I'm doing positive 50 into negative 50. So can your covariance be negative? Yes. Covariance can very well be negative, but variance cannot be negative. Individually, yes, you cannot have a negative variance. However, when you look at covariance, now it is not compulsory that covariance has to be negative, but covariance can possibly be negative if the relationship between A and B is negative. So logically, in response to a particular event, A can deviate positively from its mean. Like steel prices go up, A can deviate positively from its mean. But in response to the same event, B can deviate negative from its mean. And as a result, there can be a negative movement which can be detected by covariance. Individual variance will never be able to detect that relationship, but a covariance will be able to detect that relationship. And hence covariance can very well be positive, covariance can very well be negative. Again, currently I'm just looking at one situation, that is there is a change in steel price. There can be other situations as well. So there can be 10 possible price moves. and there can be a possibility that in response to one of the events, let us say over here, we can see that the movement is negative. Sometimes, let's say if India's GDP is increasing, it's a positive news, both of them will deviate positively. If there's a war, then both of them will deviate negative. I mean, both of them will go down. So there is a, I mean, I'm for simplicity, I'm just teaching you response to a single, but there can be 10, 15, 20, 30 price data points. So you will sit and find the covariance. What you need to remember from a student standpoint is the covariance can be positive, it can be negative, it can also be nil. Now I got the covariance. Why did I wanted to find the covariance? Well, covariance I wanted to find because it is useful for correlation. So I somehow find the covariance. Like for example, A minus A bar, that is 50, into B minus B bar, that is negative 50, and this comes to, let's say, 2500 negative, upon the standard deviation of A, which is 50, into the standard deviation of B, which is 50, and hence this comes to 2500, which comes to a -1. So your correlation, at least in our example, we'll do detailed problems as well, but in our example comes to a -1. Now, you remember there was this property of correlation that it had to be between, so if your correlation AB, you were taught that it had to be between +1 and -1. Have you heard about this property of correlation? Can you tell me why? Why? Did you ask why does my correlation has to be within this range? Well, like beta can be anything. Beta can be 1.5, 2.5, elasticity, why does correlation, not just for stocks, for anything that you calculate, why does correlation have to be range bound? Why does it have to be between this +1 and -1 barrier? Well, it is because the way the correlation formula is structured, no matter what you do, your answer cannot exceed +1, your answer cannot go less than -1. Now, how? Well, I'll just try to explain it to you probably in a simplistic way. Otherwise, if you remember this formula, it is more than enough from an exam perspective. It is because if I were to ask you, let us say for simplicity, let's say you have 6 subjects in your CA final. Let us say for everything that you do correct, let's say, I mean, just please pay attention to this example so you'll understand correlation perfectly, okay? Let's say there are six subjects in your CA final, and let's say institute makes a change that all of them are MCQ based. So it's 100 mark MCQ. So we are very happy, but then institute also comes with the catch. It says that there'll be negative marking as well. So if you do a particular problem right, you get 1 mark positive. If you do a problem wrong, you get 1 mark negative. Okay, so then we'll say we'll leave the CA course. We are already on the verge of it with negative marking. We'll go ahead, but let's say that's a separate story. So 1 correct mark will give you 1 mark, 1 wrong mark, 1 wrong sum will give you a -1 mark. Now you have 600 problems. Let's say there is 600 marks. So you have 600 questions. If you do each and every question correct, what is the maximum marks you can get? What is the maximum marks you can get if you do each and every question correct? Well, we can get 600 marks. Sir, what is the relation with this? Well, when I look at the denominator, this is when I look at the correlation formula, and if in the correlation formula, when I look at the denominator, that is standard deviation of A and standard deviation of B. This standard deviation cannot be negative. Why? Because the way it is calculated, it is A minus A bar the whole squared into B minus B bar the whole squared. So total you'll get 600 marks. That is correct. Kya baat hai? You are going to set a new record now. So when I do each and every sum correctly, what I am going to land up, so this formula says covariance of AB upon standard deviation of A into standard deviation of B. Now, when I look at the numerator of this formula, covariance is A minus A bar into B minus B bar. And in my denominator, what I do is, I would say, okay, this is standard deviation. So this is A minus A bar, the whole squared. And then you square root it. So this is A minus A bar the whole squared, and then this is square rooted, and this is summation of b minus b bar the whole squared, and then this is square rooted. I'm ignoring n for the timing, but this is your logic. Are barabar ke nahi? Now the thing over here is, after a square and square root, this number has to be positive. After a square and square root, this number has to be positive. But in the numerator, a minus a bar can be positive or negative, b minus b bar can be positive or negative. So basically, this formula, what it says is, in the numerator, you will take a minus a bar into b minus b bar. In the denominator, it will take, in a way, a minus a bar, but in positive terms only, because you have squared and square rooted it. You will take b minus b bar, but in positive terms only. So what I'm trying to say is, your denominator shows your maximum possible positive co-movement. Maximum possible positive co-movement. So basically, if you get each and every sum correct across this 600 questions, you are going to get one positive mark, and you are going to get 600 marks. So in the denominator, it's 600. But in the numerator, you might do one question correct, one question wrong, three questions correct, one question wrong. In your numerator, you are going to get your actual marks. So your actual marks, let us say, kitna chahiye aapko? How much do you want to score? Sir, you want to score 450 marks. So let us say you score 450, you get some questions right, some questions wrong. And as a result, when I look at 450 in the numerator, that is your actual movement. In your actual co-movement, something has gone positive, something has gone negative. Maybe if you are extremely sharp, you get all the sums correct. Well, you get in the numerator, you can't get more than 600. There is no chance you can get more than 600. However, you have special talent and you get all sums wrong. Even if you get all sums wrong, you cannot score less than minus 600. And as a result, over here, I mean, if you get all the sums wrong, that requires special talent. But if you have that, then you will land up with a negative 600 score. So negative 600 upon, again, it is -1. It can't go below -1. The way correlation formula is structured is, in the denominator, it will take the maximum possible positive co-movement. If everything goes positive, everything goes correct, how much will you score? 600. However, in the numerator, you take the actual co-movement, that is something positive, something negative, I don't know. So ultimately, you end up scoring 450. And that 450, if you tell your engineering friends or your science friends, oh, I've scored 450 in CA, they will have a question mark on their face. They don't know whether to congratulate you or to give you a shoulder to cry. But if you tell them, I scored 75%, that is 450, I think that's correct. 450 divided by 600. Chalo, abhi bhi thoda maths aata hai. 75%, 0.75. In which case, then they will ask party from you. So correlation gives you that relationship that, okay, out of the 100 marks, let us say 75% you managed to score correctly. So correlation gives you the relationship, but it cannot be more than 1, because the way formula is designed, there's an actual co-movement. Even if actually everything goes positive, you will score 600 on 600, that is 1. Everything goes negative, you will score minus 600 upon 600, that is -1. There, if you score something right, something wrong, then you will be between this, but you cannot cross this barrier if you want to understand. Is this clear broadly? Okay. As I said, we'll spend around 35-40 minutes to understand all that has happened. If you understand it, brilliant. If you don't worry. From an exam perspective, you don't need to necessarily remember all of this. The next 5 minutes, what I'm going to discuss is from a pure exam perspective. And if you kind of get a hang of that, perfect, you are good to go. All of these earlier things that we discussed is more for your understanding on what things are going why. But let us say, if that is a challenge, nothing to worry. What do I need to remember from an exam perspective? From an exam perspective, if a question comes where they tell me to calculate the standard deviation of AB, that is a portfolio risk, I will calculate it as A plus B the whole squared, that is W squared A into standard deviation squared A plus W squared B into standard deviation squared B plus 2 into WA, WB, standard deviation A, standard deviation B into the correlation of AB, where correlation of AB will be calculated as the covariance of AB upon the standard deviation of A into the standard deviation of B. Why we discussed all of this logic is, if by chance you forget a formula, because this is just the beginning of your AFM, you'll have a lot of formula. if you even forget what is to be done, if that concept is clear, you will know, okay, I need to multiply correlation here. Okay, correlation is actual divided by maximum. You will never ever need to by heart a formula again if you understand the rationale behind this. So over here, just a second, what is happening? Screen is not visible. Just a second. Even our screen has given up. Abhi dikh raha? Okay, so even the screen got freezed, our mind got freezed, everything got frozen. But okay. So what I'm telling you is the rationale for doing all of this is if you invariably end up forgetting a particular thing, you will still be able to build it back. Those building blocks should be there. So correlation is calculated, and where covariance is calculated as summation of A minus A bar into B minus B bar. Will I square root this? No, that's about it. So if you remember these three pieces, you are in a good shape to solve any of the portfolio risk questions. Are we clear with this? Yes? Okay, so over here, this gives you an understanding of your overall portfolio, and that is why if you have heard the concept of diversification, you have heard people saying you should always diversify, don't put all your eggs in one basket, etc. Diversification is exactly this. When I bring in two stocks, I mean, we are just talking about two stocks, a portfolio might consist of 30, 50 stocks. If I bring in, let us say, two stocks into my portfolio, what I also have to look at, except for their individual risk, is also how they react with each other in a larger portfolio setup. So as I proceed further into a portfolio setup, my portfolio risk also looks at the co-movement. So if I bring in a new stock into my portfolio, if I decide to introduce the third stock into my portfolio, ideally people would say you look at the return of the third stock, you look at the risk of the third stock. Yes, you look at that. However, you also have to look at how this third stock is going to react with stock A and stock B, that is your portfolio. Maybe you're bringing in a stock which has a slightly negative correlation, in which case that will reduce your portfolio risk. So over here, my objective is to reduce the portfolio risk. Now, you might bring in a stock which individually has very high risk, but if it has a negative correlation with your portfolio, well, it can actually reduce portfolio risk. I mean, if you're okay, I can just spend 5 more minutes and discuss something which can probably help you. It may not be relevant from an exam perspective, but it is very, very relevant from an understanding and so, I mean, just it's a different concept. But let us say if I were to go into a 3 security portfolio, for example, then can you build the formula for a 3 security portfolio? Well, do I know A plus B plus C the whole squared? A squared plus B squared plus C squared. Achha, then what? A squared plus B squared plus C squared, then what? Someone will say 2ABC. G nahi, there is no 2ABC plus 2AB plus 2AC plus 2BC. So if you remember, so if I want to calculate the standard deviation of ABC for a 3 security portfolio, this will be weight squared A into standard deviation squared A plus weight squared B into standard deviation squared B plus weight squared C into standard deviation squared C plus 2 into weight of A, weight of B, standard deviation of A, standard deviation of B into the correlation of AB plus 2 into weight of A, weight of C, standard deviation of A, standard deviation of C into the correlation of AC plus 2 into weight of B, weight of C, standard deviation of B into standard deviation of C into the correlation of BC. Okay. If I go to the 4 security portfolio has never come for a portfolio, never. I'm using the word never. So forget 4, 5, 10 security portfolio. But if it comes, then there will be a massive square root. So if you go to see, I'm not writing the entire thing, it will be a squared plus b squared plus c squared plus d squared plus 2ab plus 2ac plus 2ad plus 2bc plus 2bd plus 2cd. Similarly, if I go to a 5 security portfolio, can you see as I increase my number, listen to this carefully, what I want to share with you. As I increase the number of securities in my portfolio, currently I only have 4. Let's say I go to 5, let's say I go to 6, let's say I go to 7, let's say I go to 30 securities. Let's say it's a very typical to have a 30 security portfolio. Let's say I have 30 securities in my portfolio. Then when I decide to add the 31st security, let's say I decide to add 31st product in my portfolio as gold. I have 30 shares. I now say, let me add gold, that is the 31st item in my portfolio. What will be added? There will be one variance term, that is gold might have a very high standard deviation. You'll say, oh, gold is very risky, very risky. Let's not add gold. I don't want to increase the risk of my portfolio. Your objective is to reduce portfolio risk. Do you agree with that? Acha. So if I add gold into my portfolio, I'm scared that gold has very high standard deviation. Gold will increase my portfolio risk, because when I add gold, the 31st security, then I will, like a squared plus b squared plus c squared, I will add weight of gold into the standard deviation square of gold. However, when you become a portfolio manager, your main concern will not be the individual standard deviation of gold. That is just one term. However, when I add the 31st security, listen to this, will there be another 30 correlation terms, like correlation of 31st security, that is gold, with the first security, 31st security gold, that with the second security? Are yes or no? When I add D into my portfolio, I added 1, I added 2, I added 3. I said the first 3 securities ke saath, how does D react? In a similar way, when I add the 31st security, that is gold, I have to see how does gold react with the other 30 securities. And if gold is reacting negatively, like gold is the only asset class which historically has a negative correlation with shares. That is, if the share market is going up, recently things are different, but if the share market is going up, gold price goes down. If the share market goes down, gold prices go up. Why? Because people say that if share market is going down, they want safety, so they sell their shares, put money in gold. When the share market is going up, they will sell gold, get the money and put it in shares. So it has historically a negative correlation, and hence as a portfolio manager, when you add that 31st security, you are more concerned with the co-movement on how that security moves with the other securities, instead of just their individual movement of gold. Typically, people at an individual level will only think, oh, gold is very highly risky. But see how much diversification gold brings. Because if gold has a negative correlation with the other 30 securities, there will be one standard deviation term of gold which will be added, but there will be another 30 terms which will be negative, and that will pull down your portfolio risk. So if you understand this, I mean, this is just additional insight, but if you understand it, great. Otherwise, what you need to remember from a practical standpoint is, if you are going into a portfolio management profile, what you look at is not just the individual security risk that is to be looked at, but how does that individual security react with the other securities in your portfolio? What is that correlation? Because that is, there will be 30 more correlation terms which will be added as against just a single standard deviation term that gets added. Are we clear with this? So that kind of brings that diversification, and that is why we say that when I diversify my portfolio, that can help me in reducing portfolio risk. As long as I'm adding securities in my portfolio, if see, all of these terms are positive, standard deviation, weights, all of these terms are positive. So if my correlation is negative, that will reduce my number. So if I can select securities which have maybe a negative or a low positive correlation, that can bring down my portfolio risk. If it's a high positive correlation, then my portfolio risk is not reduced. But if I diversify by selecting securities with a negative correlation or maybe a low positive correlation, so that the third term becomes lower, that will help me in reducing portfolio risk. Are we clear with this? Practically, how does it reduce? This is exactly how it will reduce practically. Like over here, if you had invested in only all auto company stocks, like you had invested in Maruti, you had invested in Mahindra, you had invested in Tata Motors, then in response to a steel price change, your portfolio would have actually fallen. However, because you diversified and you invested in securities which were having a different movement, you hedged your risk. Like even if there was a fall in price, that got negated by a rise in price of some other stock. So that way, practically your portfolio gets protected. Okay, chalo. So I think I will kind of stop for now. I think you have gone through a lot. Have a जाके अभी अपने मुंह धो के आना पड़ेगा अपने को. But I hope that you've got some good clarity, and this is something which requires detailing, like beta requires detailing, CAPM requires detailing, portfolio risk requires detailing. So we would want to spend some time over here. Let's get on into the theory and then see how we are going to solve questions based on this. So go to page number 38 of your shield. Yes, negative correlation will not help you in generating a very high return, but it will protect you from risk. Currently, we are just looking at risk. When you look at return as well, your art is to balance the risk and return. Here, we are only discussing on how to reduce the risk. How to optimize the return, we'll have to review that separately. Okay. So if I look at portfolio risk, this formula is sometimes called as the Markowitz formula, coming from modern portfolio theory. So sometimes institute says calculate standard deviation using Markowitz formula. You will say, "Arey sir ne kuch padha hi nahi." Or modern portfolio theory, it is the same formula. It is the same formula whether it is just asking portfolio risk, portfolio standard deviation, Markowitz formula, or modern portfolio theory. Ideally, portfolio risk should be calculated in the same manner as portfolio return. So that is the weighted average. However, mere weighted average cannot give us portfolio risk. Why? This is because standard deviation is always calculated as a positive number, whereas the return can be positive or it can also be negative. Therefore, the two securities in a portfolio may deviate, but in opposite directions. Hence, while calculating portfolio risk, we should consider the co-movement of the individual securities in the portfolio, and therefore, we are saying that this is not possible. Therefore, the portfolio risk can be calculated as follows. So you will have this formula, and the most important thing is the correlation that I'm multiplying at the end. This is the Markowitz formula. Taking the square root, we can find the standard deviation, that is a portfolio risk. The formula is same as a plus b the whole squared, with the correlation term being multiplied only to the third term. Why? Because the third term only captures co-movement. Because the third term captures co-movement. Now, how do you calculate correlation? For that, we find covariance. Covariance is x minus x bar into y minus y bar upon n. That is if there are no probabilities. If there are probabilities, the same principle applies. Instead of dividing it by n, you will multiply it by p. That's about it. You will not square root the covariance, and covariance is an absolute measure of risk, can be positive, can also be negative. Variance cannot be negative because it is squared and then square rooted, but covariance can very well be negative. Okay, next we have correlation. As we said, correlation is a covariance upon the standard deviation of x into standard deviation of y. Sometimes there's another term called as coefficient of determination. This is nothing but correlation squared. Like standard deviation squared is called as variance. Correlation squared is called as coefficient of determination. Correlation is a relative measure of risk and is always between -1 and +1. We discussed why. Rearranging the above formula, okay, there's also a shortcut that is mentioned over here. So if I look at the correlation formula, this is your correlation formula. Now, if I rearrange the correlation formula, this can also be correlation of AB. I can take standard deviation A. I can take standard deviation of B on the other side. This will equal to covariance of AB. So correlation AB into standard deviation of A into standard deviation of B will give you the covariance of AB. So this is also just a rearrangement. So there is another way in which covariance can be calculated. Given a correlation, you can just rearrange this formula. In fact, This can be substituted in the main formula. If I see what is put in green above, this is the same thing. So eventually, if you want to take a shortcut over here, we can say that, well, alternatively, standard deviation of AB can also be calculated as weight squared A into the standard deviation squared A plus weight squared B into the standard deviation squared B. Now in the third term, you have 2 of weight of A into weight of B. Now you have standard deviation of A into standard deviation of B into the correlation of AB. So instead of these terms, you can multiply it by covariance. So this term gets replaced by covariance. So this is basically the variance of A plus the variance of B plus the covariance of A and B. That is what this formula can kind of narrow down to. So we are saying, rearranging the above formula, we can get another way to calculate covariance, and the third term, which was essentially standard deviation of x into standard deviation of y into correlation of xy. This is nothing but the covariance of xy. This can also be a way to calculate. So you have diversification. In case securities in a portfolio have a negative correlation or a low positive correlation, then the third term in the portfolio risk calculation would fall or will be reduced, and hence the overall portfolio risk would also reduce. So if you're calculating risk, there is the first term, there's a second term, there's a third term. In the third term, you're multiplying by the correlation. If that correlation is negative or it has a low positive, the third term will be smaller, and thereby your portfolio risk will be relatively lower. This risk reduction is considered to be the benefits attributable to diversification. So when they say, when you diversify, you reduce the risk, this is how actually your risk gets reduced. Okay, now we'll try to discuss a couple of problems. One of the problems we'll do together, and then the second problem I will let you try on your own. There's a process that we need to follow to get these answers. So these are practice questions, as you see. I mean, it's there in your classwork book only, but you see there's no source. So it's not an institute study material question. It is just a question which will help you build up your overall understanding. So go to page number 144. We'll do question number 6 together, and then I'll let you do question number 7 in a manner that we discussed for question number 6. You should be able to do it properly. So let us try question number 6, and you will pay attention in the format that I use. Well, that is one of the ways I prefer doing it. There can be alternative ways, but this is the way I prefer, and I've seen students making the least possible silly mistakes in this particular method. So let us say, we will start question number 5. Are we there? Go to question number 5, please, on page number 144. Sorry, question number 6. 5 is done. Question number 6 on page number 144. So you have the state of economy, boom, normal recession, probabilities, returns of A, returns of B. Thankfully, they've been given in percentage terms. If they were not, you would sit to calculate that in percentage terms first. Why only the third term captures co-movement? Because standard deviation of A into standard deviation of B is only coming in the third term. In the third term, see, the risk is a sum total of the risk of A and the risk of B. So first and the second terms only individually calculate risk of A. It is standard deviation of A squared. B may only standard deviation of B squared. It is the third term where A and B are multiplied, and hence that intermingling happens in the third term only. What is the expected return of securities A and B? Oh, so they are asking me to calculate A bar. They are asking me to calculate B bar, expected return. What is the risk attached to securities A and B? Which means they are asking me to calculate standard deviation of A. Then they are asking me to calculate standard deviation of B. They are not asking me to calculate portfolio. Calculate the risk and return of the portfolio consisting of 50% A, 50% B, and then 60% A, 40% B. So over here, when we look at the point B of the question, they are asking me to calculate portfolio return, portfolio risk. Now my point is, even if subpoint A was not asked, यहाँ पे तो subpoint A is asked. Even if subpoint A was not asked, if you are only asked to calculate portfolio return or portfolio risk, you will still have to calculate the standard deviation of security A, standard deviation of security B. You will still have to calculate the return of security A and B. So irrespective of whether point A is asked or not, you'll have to calculate the standard deviation of A, standard deviation of B. You'll have to calculate A bar, you'll have to calculate B bar. Also, you need to calculate covariance, because if portfolio risk is asked, you need covariance. Covariance forms a base for correlation, but you need to find covariance. So what do? We will typically prepare what I call as a 7-column table. Listen to this carefully. You have to ensure that in your books, write this along with me. And the next problem that you do it on a similar base. So when you uh, when you try the 7-column table, you have to ensure that it fits in this one line. It's not that 6 columns come, then the 7th column goes below. If you do that, I mean, that is also fine. But then the chances of making a silly mistake increases, because when you're looking everything in one horizontal line, it's easier. So try to ensure that these columns fit in a set line. So out of these 7 columns, the first 4 columns will be from what is there in the question. And you can look at, the last 3 columns will need more space. The first 4 columns you can squeeze in. It is the same data set as the question. So over here, question number, what is this? Question number 6, if we do this together. So you don't have to write this entire state of economy, boom, nor you can just write in short as well. So let's say this is state, this is boom ka B, leave a line, normal ka N, and there is recession R. So let's say you leave a line, then you will mention, let's say there's probability A is written, B is written. What I preferably prefer is you will find A, write percentage sign over here, so you don't have to keep on writing percentages everywhere. B, write the percentage sign over here, and then you write those numbers, 30, 20, 10, 10, 20, 30. Okay, there's also a probability. So you'll say probability in short and into bracket P. So you are saying that when I use the word P, it means probability. 0.2, 0.6, 0.2. So this is 0.2, 0.6 and 0.2. Okay. So you still have enough. I mean, this should not take more than, let's say, 1/3 of a page. You will still have enough space. Now, what do I need to do? Well, I need to calculate A bar. I need to calculate B bar. I will not prepare separate columns for this. I will do this below. And I will say, what is A bar? Well, this is summation of P into A. That is 30 into 0.2 plus 20 into 0.6 plus 10 into 0.2. You will get an answer. Similarly, you will find summation of P into B. Can you tell me what is the answer? 10 into 0.2 plus 20 into 0.6 plus 30 into 0.2. So how much is this? Can you tell me the answer? Well, this is 20. This is also 20. At the end, if you want, you can put in the percentage sign as well. So we'll put in the percentage sign at the end if required. So I have the A bar, I have the B bar. What do I need to calculate now? Well, students would say I will need to calculate the standard deviation of A and standard deviation of B. Before that, I personally prefer if you calculate covariance. So at this point, you will sit and calculate the covariance and then you calculate the standard deviation is what I personally prefer. Now, when I calculate the covariance, what is the formula? The next column, the 5th column is a covariance column, P into A minus A bar. What is the A bar? 20. Write that 20 over here. In this case, coincidentally, A bar and B bar both are 20, but that is not always the case. Then you have B minus B bar. So this is B minus 20 again. So this is how you have to solve. Now, once you have written this, I would want you to solve it vertically. Listen to this carefully. I will want you to solve it vertically means I will first write down all the probabilities such as 0.2, 0.6, 0.2. And then I will write down all the A minus 20 terms so that I don't, otherwise there is a chance you can make there are only 3 observations. There can be 10 observations also. We'll do a sum with 10 observations. So over here, you will only look at this number that is 20 and you will look at this column. So you're not confusing anything. So you have 30 minus 20 that is equal to 10 positive, 20 minus 20 that is 0 and 10 minus 20. Achha, if it is negative, I'll put this in brackets. That just minus sign, it is possible that I can overlook it. So I'll put it in brackets. Then I will do vertically B. So when I do vertically B, I'm only going to look at this 20 and I'm going to look at this column. So this is 10 minus 20. That's a minus 10. 20 minus 20 is 0. 30 minus 20, that is equal to positive 10. So I will then write down these numbers and do the working. So this is what? I think minus 20, 0, and again minus 20. So if I total this up, this will come to a minus 40. This will come to a minus 40. So what do we remember? We first write down the 4 columns as given in the question. Then we calculate A bar and B bar. Why? Because A bar and B bar will be used for correlation, covariance. It will also be used for variance. We find A bar and B bar. Then we find the covariance. While we are finding the covariance, we will solve it vertically. That is, you will first note down the P probabilities, we'll then note down A minus A bar, then we'll finish off B minus B bar, and then we'll do the multiplication. If there comes to be a negative sign, we'll put it in brackets. If there's a positive sign, we'll keep it as it is. Okay. Next, we will find P into A minus A bar the whole squared. Now, technically, you will again have to calculate A minus A bar. However, have I already done this A minus A bar calculation here? So what I just need to do is square it. I'll again repeat. I don't need to, the lesser you focus on calculating it once, A minus A bar. Now, if you have done that properly, then again, you don't need to calculate A minus A bar. We don't want to make a silly mistake, because if you do a mistake, there's no way in which you will be able to detect this. It is just after the exams, when you get the certified copies, you will rack your brains. So we have to ensure that we make the least possible chances of an error. So over here, you will have 10. So 10 into equal to, that is equal to 100 into 0.2. So this comes to 20. This 10 into 10. So that is 10 squared into 0.2. So this is 20. 0 squared into 0.60. Negative 10 squared. That is again 100 into 0.2. That is equal to 20. So don't worry. This sum I'm discussing. Second sum you are going to try on your own. And you will apply all of these concepts on your own. So this is 40. Similarly, you do P into B minus B bar. And this will be 0.2, again 20, 0 and 20. So this comes to 40. Now this is a 7 column table. 7 column 1, 2, 3, 4, 5, 6, 7. So these are my 7 columns, and this forms the base of most of your portfolio workings, whether you go ahead and calculate beta or you calculate portfolio standard deviation or multiple things that you will do. Most of your data points will come from this 7 column table. So now if I want to calculate, let's say standard deviation of A, I will write down the formula so that the examiner knows. Summation of P into A minus A bar the whole squared. Well, I've already calculated A minus A bar the whole squared in column number 6. That is 40. But I will have to square root this. So this is 40 square rooted comes to 6.32, let's say, percentage. Standard deviation of B will be under the root. Summation of B minus B bar the whole squared. So this is also multiplied with probability. This is also coincidentally 40. If I square root it, I will get 6.32%. Okay. And I will find covariance. Now covariance of A and B will be summation of P into A minus A bar into B minus B bar. And hence this will come to, let's say, negative 40. Do I need to divide this by n? Not needed. Do I need to take the square root? Not needed. Why? Because this is a covariance term. And hence you will then try to find a correlation if required. Remember, you can even do this without the correlation. You know the formula to apply it without the correlation. But if you want to find a correlation, this will be covariance of AB upon standard deviation of A into standard deviation of B. This is negative 40 upon 6.32 into 6.32. So this comes to negative 40. And if I multiply 6.32, I mean, that's actually 39. That is approximately 40 only, because 6.32, if you take the full decimal, this was 40 only. So this will come to a negative 1. Correlation comes to a negative 1. Okay. Now we want to find, so we have found the expected return of A and B and the risk attached. Now we want to find the risk and return of the portfolio consisting of 60, 40 and 50-50. These are the weights. So if I go to point B, we want to find at weight of A, which is 50, and weight of B, which is also 50. If I find the return of AB will be the weight of A into the return of A plus the weight of B into the return of B. So this is 0.5 into 20 plus 0.5 into 20 comes to, let us say, 20. And standard deviation AB, if I go to see under the root, we'll note down the formula: weight squared A, standard deviation squared A, weight squared B, standard deviation squared B, plus 2 into weight of A, weight of B, standard deviation A, standard deviation of B, into correlation of AB. Everything we have calculated. We can even do covariance directly. So if I were to apply this, this will be 0.5 squared multiplied by 6.32 squared, which was 40. Again 0.5 squared into 6.32 squared, which is 40, plus 2 into 0.5 into 0.5 into 6.32 into 6.32 into a minus 1. So if I were to do this working, this will be 0.5 squared, that is 0.25 into 40, that comes to a positive 10. Again, this comes to a positive 10. 2 into 0.5 into 0.5 into 6.32 into 6.32. That's again 40 into minus 1. So this comes to a minus 20. And thereby this comes to 0. So here this is an extreme case where you have two securities which are exactly oppositely correlated. You are holding them exactly 50-50, and hence you have managed to eliminate portfolio risk. So this is one possibility. There is another weight setup over here of 60-40. Again, at this point things may appear to be a little blurred, but that is why question 7 is kept for you and you will try it right now only. We'll just discuss this first. I'll give you some lead time to start question 7 before me, and then we will discuss. So that sir, does a return and correlation have the same short form R? For it, okay, I mean usually yes, but for return we can use the capital R. For correlation we'll use the short form, I mean the lowercase. But I mean, if you are confused, you can always write the word COR for correlation, that is fine. So if I look at the second case, that is a weight of A being 60 and the weight of B being 40. Again, the return of AB will be 0.6 into 20 plus 0.4 into 20. That comes to, let us say, 20 only. And when I look at the standard deviation of AB, this is the same formula as earlier. We don't need to write it again. 0.6 squared into 6.32 squared, 0.4 squared into 6.32 squared, 2 into 0.6 into 0.4 into 6.32 into 6.32 into again a negative 1. So if I were to take these numbers, this is what? 0.6 squared into 40 comes to 14.4. 0.4 squared into 40, 6.4, and minus 2 into 0.6 into 0.4 into 40. That comes to, I think, 19.2. So if I do this working, probably I will get 1.6, and if I were to square root 1.6, that is around 1.26. So I will get, so here you have negatively correlated securities, but you're not holding them exactly 50-50. You're holding 60-40, and hence there is some risk which still remains around a 1.26% risk. How many decimals should we need to take? Well, if you're doing this finally, 2 decimals should work. Okay, perfect. So you will apply everything that you have studied over here on your own. I'll give you some lead time of a few minutes, but you will start and then we'll discuss. We'll read question number 7. This is something that you will try. So this is try right now, not for homework, right now, so that your concepts, your steps get cemented. Do it properly in pen and paper. Ensure you have that 7 column table, out of which the first 4 columns you'll write it as it is. Then you will calculate A bar and B bar. Then you will use that for the purpose of covariance. Then you will use that for the purpose of standard deviation. Following are the different states of economy, the probabilities of occurrence, and the state and the expected rate of return for securities A and B in the following different situations. You have recession, normal, boom, again probabilities. Acha, security A over here is a minus 15. In the beginning only security is minus 15, so we'll put it in brackets. Minus 15, normal is 20, 60. Then security B, you have 20, 30, 40. Find the expected returns and standard deviation of these two securities. So you have to find A bar, B bar, standard deviation of these two securities, which means you need to find standard deviation of A, standard deviation of B. Suppose an investor has 20,000 to invest. If he invests 15,000 in security A and the balance in security B, what is the expected return and the standard deviation of the portfolio? Well, over here you will have to find the weights. Well, the weight of A is 15,000 out of 20, that is equal to 75% weight of A, and the remaining will be in B. So the weight of B will be 5,000 out of 20, and hence that is 0.25, and that's about it. Will we be able to try this on your own? Yes? Okay. So pause and try on your own, please, and you should be able to get your workings in place. Get started. Hello, can we start? I think you have had a good head start. Yes, you can directly use the covariance formula, skipping the calculation of correlation. Definitely, yes. We just did that because it was our first question, and multiple revisions of our question bank is enough. Definitely, yes. So, are you able to calculate at least the A bar and B bar till now? What is the A bar you are getting? So you will prepare this 7 column table. You'll have conditions A, B, and probability. You will write all of these and then you will do the A bar calculation that should come to around 25. And B bar, you will come to around 31. That is right. 25 for A bar, 31 for B bar. So this is perfect. Then you go into the correlation working, which is the most covariance working. 31 for B, perfect. So that is in a good. Now the most important thing is the covariance, that table where you do P into A minus A bar and B minus B bar and solve it vertically. Let me know once your covariance gets done. Also like the video by in the meantime while you're doing this. Let me know once your covariance gets done. Okay. So we see 185 over here. What you would have done is you would have first written the probabilities 0.2, 0.5 and 0.3. Then you would solve it vertically. While you're doing it, you would have written A minus 25 the whole squared. It's fine if you write A minus A bar, but I prefer if you write A minus 25 so that, not whole squared, A minus 25. I think this is whole squared is wrong. So A minus 25 and then B minus 25 is what you kind of need to B minus 31 so that you don't make a mistake in picking up the numbers. So you have negative 15 minus 25 comes to negative 40, you put it in brackets. 20 minus 25 negative 5, you put it in brackets. 60 minus 25, that comes to 35. So that is A minus A bar, then B minus B bar, that is B over here minus 31. So that is 20 minus 31 negative 11, 30 minus 31 negative 1, and then 40 minus 31, that is a positive 9. You multiply this and you will end up getting 185. Then when you calculate P into A minus A bar the whole squared and P into B minus B bar the whole squared, you will have to take these numbers only. So you will take 40, directly square it and multiply it by 0.2. 5, directly square it, multiplied by 0.5. 35, directly square it and multiplied by 0.3, and you should be getting 700 and 49. Let me know once you're done with the other workings as well. So you'll have A bar, which is 25, B bar, which is 31, standard deviation A, which is the square root of 700, standard deviation of B, which is the square root of 49. So this is 7, whereas the square root of 700 is 26.46. Covariance is 185. As you were suggesting, can we use covariance directly? Okay, so in this sum, I mean, you can calculate correlation and solve, but if you want to use covariance directly, most welcome, you can do that. So over here, if I were to calculate the return of the portfolio AB, this is weight of A into the return of A plus the weight of B into the return of B. Here they have not given you these weights directly, but you can easily calculate 15 out of 20, that is 0.75 into the return, which is 25, plus 0.25 into the return, which is, let us say, 31. So this is 25 into 0.75, 31 into 0.25, and this comes to 26.5. And when you calculate the portfolio standard deviation, I want you to do this on your own, please, and let me know once this is done. Let me know once this is done, please. So if I look at this working here, I would say 0.75 squared into 26.46 squared plus 0.25 squared into 7 squared plus 2 into 0.75 into 0.25 into, I can directly take the covariance of around 185, and hence if I do this working, this is 0.75 into equal to and around 700, so this is around 393.75. There may be some decimal differences. 0.25 into 49, there is 3.0625, and there is 2 into 0.75 into 0.25 into 185. This comes to around 69.375. And if I were to square root this is around 466 point something, and if I were to square root this, I will get 21.59 approximately. Is everyone clear with this? Is everyone clear? Okay, now I want to discuss an extra thing for you. This is absolutely fine if you do it this way. However, had you calculated correlation, what will be the correlation? Well, the correlation of AB would be the covariance of AB, which is 185, upon the standard deviation of A into the standard deviation of B. Please pay attention. So over here, correlation is, this is 185 upon 26 point, what was it? 26.46 into 7. So this is 185 divided by what? Well, 26.46 into 7 also comes to approximately 185 only. And hence, what is the correlation? Well, the correlation over here comes to 1. Now at this point, I want to discuss with you a particular shortcut. So if the correlation comes to 1, in this case plus 1, or let's say at the other extreme minus 1, then the formula that we were discussing, this big formula that is there, that is a plus b the whole squared. Now in a plus b the whole squared, that is a squared plus b squared plus 2ab. We are multiplying 2ab ke saath correlation, but if that correlation is 1, can I say that term, the third term, is the same as a plus b the whole squared? I'll again repeat mathematically. If you get this, it's shortcut, will save your time. So when I look at this third term takes 2ab, but it multiplies 2ab with the correlation. If the correlation is exactly plus 1, then it is 2ab only. So ideally this is a plus b the whole squared. करने के लिए you need a squared plus b squared plus 2ab. But अपना a plus b the whole squared नहीं हो रहा था. Why? Because you were multiplying it by the correlation. 2ab term you are ultimately multiplying by the correlation. But if your correlation is exactly 1, then this term will equal to, if your correlation of AB equals to 1, then this will become a plus b the whole squared. So when I'm doing this standard deviation of AB, rather than doing this big square root, I will say, well, you know what, this will shrink to WA into standard deviation of A plus WB into standard deviation of B the whole squared. And if I square root this is nothing but the weighted average. Remember, the weighted average did not work because maybe your correlation was not exactly equal. But if your correlation is exactly equal, you can see, like in this case, that you will get exactly the same answer. Like if you take weight of A 0.75 into the standard deviation, that is 26.46, plus weight of B, that is 0.25, into the standard deviation, that is 7, you should ideally get the same answer. 0.75 into 26.46 and 0.25 into 7, just a second, 0.75 into 26.46 and 0.25 into 7, this comes to 21.59. Sir, will the marks be deducted if I'm using shortcut? Not at all. Remember, you're not writing a BCom paper, you're writing a CA paper, and in case a shortcut you know and you can apply, that's very well accepted. In fact, if you don't remember this and you solve it in the longer way, there is no problem in that. So it's just what we call it as a conditional shortcut. That means in case conditions are met, like correlation is +1, then it is a plus b the whole squared. If the correlation was -1, it would be a minus b the whole squared. But let's say if the correlation is +1, then you can directly do the workings and get the answer in a much more faster way. Are we clear with this? Yes. So over here, we have written alternative method. Only when correlation is +1, we can directly calculate portfolio standard deviation as weighted average, and this will give you the answer at 21.6. So this is the explanation for that, in case you are interested. But that takes care of question number 7. Okay. Now we'll stop for a well-deserved break, and we will be back in around 15 minutes. So let's stop for a break, and then on the other side we'll continue with the portfolio risk discussion. Okay. Hello. Can you please confirm if the audio and video is clear? Can you please confirm if the audio and video is clear? Okay, so let's continue and we'll proceed further into this section. The next thing that we need to do is pertaining to something called as short selling, and then there is something called as theory of dominance. It sounds to be really big, theory of dominance, but it's quite basic. First of all, we'll understand what is meant by short selling. Have you heard the words short selling? Yes. Usually what you do is you expect, you would buy a stock if you expect the price to go up. However, what if you are expecting the price of a stock to go down? Well, if you have the stock, you should sell it if you expect the price to go down. But what if you don't have the share? Well, you can't do much. At least you can just probably, at best, sell the share. But for selling the share, you need to have the share. So what a lot of people earlier used to do is they used to sell the share in the morning, and then by the end of the day they will buy it and they will sell at a higher price, and then by the end of the day they'll buy it at a lower price, and again on the next day they will sell it at a lower price. They will sell it and then buy it by the end of the day, whatever it is. Now this was a very inefficient method, and hence SEBI and stock exchanges across the world decided that they will enter into a mechanism called as stock lending mechanism. Like if you don't have money, what do? Well, if you don't have money, you might go to a bank, borrow money from the bank and do what you want to do with the money. In a similar way, if you don't have a share, can't I just borrow the share from somewhere? Like a stock exchange would say that, well, if you're selling a share, then by the end of the day, you need to give delivery of the share. But if you don't have the share, then how will you give the delivery? Well, in such a situation, what you will do is you will borrow that share from someone. Well, but if I borrow, will I have to pay some interest? Yes, like if you borrow money, you'll have to pay interest. If you borrow a share, also you'll have to pay some interest. But you will borrow that share, deliver that share, and then wait for the time the share price falls and then buy the share back. This process is called as short selling. Now, short selling is not as popular in India, but I mean, I don't know if you've seen that movie Scam 92. I will not movie, it's I think web series Scam 92 of Harshad Mehta. Uh, Yes, sir, that music is playing in our background. Tan, 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 and tan, 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 and. So in that movie, there is other than Harshad Mehta, there is I think Manu Manek or Manu Mundra is it is shown over there. He's called as a big bear. So he's supposed to. He is a person who will short sell. He will sell stocks which he believes are going to fall in price. Whereas Harshad Mehta was a big bull. He will buy the shares which he thinks will increase in price. So over here, when I'm looking at short selling, my talent is identifying shares which I believe is going to fall, and I will sell those shares. The share price falls and will buy it at a lower price. So usually people believe that money is made in a stock market only when the market is rising. Well, that is if you are just buying those shares. But if you are also balancing your act by selling shares which you think that the price is going to fall, you can even make money in that. Like, I don't know whether if you have seen some time back, there was a report given by a company called as Hindenburg for Adani Enterprises, you remember? And then the Adani stock fell. Now, Hindenburg is globally a short seller. So they will study companies which they believe have a problem. Then they will kind of sell those companies. They will give analysis, research, why they're selling these companies. And if the stock price falls, they will buy it at a lower price and they will make a profit. So this is the process of short selling. Now, short selling is facilitated by something called as advance borrowing and lending, or in some countries called as stock lending mechanism. But from a portfolio perspective, how do we change? What changes? Well, uh, in this case as well, or if let us say you have a situation where you like stock X, so you buy X. How much money do you have? Let's say you have 100 rupees. You put that in stock X. You buy stock X. But you think there's a company Y which is not performing well. So you sell stock Y. So 100 rupees is a cash outflow for you. But when I sell stock Y, maybe I sell worth, I don't know, 25 rupees. That is a cash inflow for me. Now, typically when I take the weights, I would say this is 100 and 25, this is 125, and I will find the weights. Is that correct? So this is 100 by 125 comes to 80%. This is 20%. Is this weight calculation correct according to you? No, sir, this weight calculation is not correct. It is wrong because this is a cash outflow. I've spent 100 rupees, but when I short sell, I will give the share and I'll get 25 rupees. And as a result, you say amount invested is a weight. So 100 rupees you're investing in X, great. But at the same time, you're getting 25 rupees. And as a result, this will be a cash inflow. Your amount invested is actually a negative 25, and hence technically you can say that 100 minus 25, that is net 75, is what you are investing. 100 you are putting out of your own pocket, and then 25 you are getting as a cash inflow. So this is 75. Sir, but can the weights go greater than 1? Well, yes, in a short selling setup, the weights can be greater than 1. The weights can also be negative. Now, what sometimes the questions will tell you is, well, what do I do with this 25 rupees that I got? I invest that 25 rupees again in stock X. It is very much possible. I might say that I really love stock X. In my bank account, I only have 100 rupees. So I go all in. I put all the 100 in stock X. Then I don't think Y is doing well. I sell stock Y. I get another 25 rupees uh, in let us say by that short selling process, and I invest that 25 rupees as a cash outflow in stock X. So basically the amount that I've invested in stock X totals up to 125, whereas the amount that I have a negative weight in stock Y is a negative 25, and hence your net amount will be 100. So you have 100 rupees which you invested, then you short sold, got 25 rupees. Those 25 also you invested in stock X, and thereby if I look at the weights, this is 125 and 25, so this is 1.25, and a negative 0.25, and thereby your weight comes, total of weights will be 1. Can the weights be negative? Well, why not? Uh, so if I look at the return, let's say return of X, let's say the price of X, you expected it will go up, it actually went up. It went up from, let us say, I don't know, it went up from 1000 to 1200. So this is 1200 minus 1000 upon 1000 into 100. So let's say this is a 20% positive return. You expected the price of Y to fall, and well, it actually fell. So it fell to 900 when it was earlier 1000, and hence the price over here, it is a negative 10% return. Now, if I were to calculate the return of the portfolio X and Y, this is a weight of X, that is 1.25 into 20% plus the weight of, now what is the weight of I? A negative 0.25 into a negative 10. Now someone might say, oh, I will be sad with a negative return. Well, if I bought the stock, I'll be sad with a negative return. But if I've sold the stock, short sold, I'm happy that the price is falling because that is beneficial for me. So I will look at, for example, 1.25 into 20 comes to around 25, and a negative 0.25 and a negative 10 comes to another 2.5. So you can see that your return is 27.5. Both your calls went correct. The stock that you thought should go up, that is X, went up. The stock you thought should go down actually went down, and thereby your return is much higher. So if a question comes, and we'll do a simple problem on this, where there is, let us say, short selling, all that you have to remember is, in case of a short selling, your weight of the security short sold will be negative because there is no amount invested in that security. In fact, amount is recovered, received from that security, and hence that carries a negative weight. Are we clear with this? Why are we including the short selling in our portfolio? Why is it not a part of our portfolio? See, this is as, let us say, small retail investors, we believe that our portfolio only has shares which we have bought. Well, even shares that are short sold, will that give you a return? Like, for example, if this stock goes from 1000 to, let's say, 2000, it will result in a huge loss for your overall portfolio. Portfolio includes your positions. Positions may be buy positions, positions may be short or sell positions as well. Okay, so let us try doing this. Let's say if you read the theory for this, short selling refers to a situation where an entity sells a share that it does not own. Typically, this is done when an entity expects the price of a share to fall. That is when I will do short selling. In such a case, we will borrow the share from a broker, short sell that share using advanced borrowing and lending mechanism, also called a stock lending mechanism. After the price of the share falls as expected, we can buy the share at the reduced price and return the share borrowed to the broker. While calculating portfolio return or risk, in case a security is short sold, we need to remember that the security short sold will have a negative weight. This is the important thing, highlight this. Will have a negative weight. This is because when you are selling a security, there's no investment. Instead, we receive a cash inflow in the form of sale proceeds, and hence the amount invested would be shown as a negative number for the security short sold. Okay. Generally, sale proceeds received on short sale would be invested in some other security. Further, we need to ensure that the total of weight shall be equal to 1. So, one security might have a 1.25 weight, another might have a negative 0.25 weight, but the total of the weights will be equal to 1. Okay. So we'll try question number 8 on these lines. Go to question number 8. Again, over here, you will use a highlighter. I'll tell you the particular thing to highlight, and that's about it. Somu buys 30,000 of stock X, that's fine, and highlight this, sells short 10,000 of stock Y. There are only 2 or 3 problems in this entire chapter where short selling comes, and this is one of them. So we need to know what happens in case of short selling. So we'll not read the entire question before our exam, but we'll at least see what is the impact if there is a short selling. Somu buys 30,000 of stock X and sells short 10,000 of stock Y, using all of the proceedings to buy more of stock X. That means the 10,000 that you receive will be used to buy more of stock X. The correlation between the securities is 0.45, and the expected returns of stock X and Y are 15% and 10%, and the standard deviations are 10% and 12% respectively. What are the expected returns and standard deviation of Somu's portfolio? So usually when data is given like this in a paragraph format, you can actually use, let us say, try to prepare a table where you can summarize this data. But in this particular case, what do I need to find? Well, I need to find the portfolio return. I need to find the portfolio risk. So the return and standard deviation are given to me, but I need to find the weights. So if you want, you can just try to calculate the weights on your own and tell me. That's right. So when you return the share, you will have to buy the share and that will be the purchase price. Yes, you can find, most companies have their own Excel models, but if you even search online, you should be able to find Excel models for these. But unfortunately, as we speak, Excel is not allowed in your curriculum. Like ACCA papers do allow you to use Word and Excel on a computer-based paper. Currently, we don't have such a thing. So we'll have to do it traditionally. So when I look at weights, can you calculate and tell me the weights, please, for X and for Y? Well, X I've invested 30,000. Y I've short sold 10,000. And all the proceeds are again used to invest in X. So I have invested 40,000 in X and short sold 10,000 worth of items in Y, and hence this is net 30,000. So your weight will be 40 divided by, so this is 1.33 and a negative 0.33. That is absolutely correct. So when I look at these solution, what I need to highlight is this part, the impact over here on the weights being negative. This is one thing that you should be able to revise. So, okay, if I'm selling short, what is the impact? The weight is negative is something you should be aware. Once you're doing that, well, things are very easy. Portfolio return of X and Y will be 1.33 into the return of X, which is 15, and negative 0.33. Well, you expected that the stock should go down. Well, it did not go down. It went up. So this is 1.33 into 15. This is 19.95 and a negative 3.33, which comes to what? Comes to 16.65. So this is your portfolio return. If you look at the portfolio risk, same working, just that over here there would be the negative weight. So this is 1.33 squared into, I guess it is 10 and 12, yes, into 10 squared plus a negative 0.33 squared into 12 squared plus 2 into 1.33 into a negative 0.33 into 10 into 12, and I think the correlation is 0.45, and that's about it. Now it is just a mathematical calculation. If nothing is given, so the doubt is if there was nothing given about that 10,000, then it is not necessary to assume that the 10,000 is invested in stock X. You can always say that 30,000 is invested in stock X and a negative 10,000. Your net amount will be 20 and calculate the weights accordingly if the question is wrong. Are we clear with this? No, it is 19.95 minus 3.3 only. You can just verify it at 1.33 into 15 and 16.65. So how much are you getting as a final answer? 1.33 squared. So this is 1.33 into equal to into 100, then 0.33 into 144, 2 into 1.33, 0.33, 120, 0.45. We're getting around, I think if I'm not wrong, 145.17, and if I square root this, around 12.05. So this is just a mathematical process. If you kind of do a bit of practice, you will get this. So this is around 12.05%. That catch over here is your ability to detect and calculate a negative weight. If you're able to do that, I think by and large, you should be in a good position to apply this. Good to go? Yes? Okay. So next we will go on into question number 9, and then there is question number 10, which is 9 and 10 use a small concept called as theory of dominance. To be honest, there is no theory per se, it is common sense. Like if there are two stocks, uh, and both of them, let's say over here there is stock A and stock B. Stock A has a return of and a risk. Let us say there is return and risk of stock A and B. Let's say in the first scenario, what is happening? Let's say this has a 12% return, this has a 15% return, and both of them have a 10% at the same risk. You will, sir, please give clarity when sold stock included in the portfolio. See, whether what do you include in your portfolio? In your portfolio, you will include things where you get exposure to a gain or a loss. When you invest in a share and the share price goes up, you are going to make a profit. When the share price goes down, you're going to make a loss. So that share is a part of your portfolio. Even when you are selling a share that you don't own, what you are assuming is if I sell the share is no longer in my portfolio. This is not a share that you are owning. This is a separate share that you are selling. Like if you are buying a share, you are including it in your portfolio because that is going to give you exposure to a gain or loss. Similarly, when you're short selling a share that you don't own, later as the price changes, that will also impact your portfolio's return and risk. So it should be a part of your portfolio because you're not exiting the share. You are just short selling. You don't have this share, you are borrowing and selling. You are exposed to price movements, then you will buy, and hence it will be a part of your portfolio. Why one stock sold included in portfolio? Because that stock is not in. I it is not stock sold that you already owned, it is a stock short sold. So you are creating an exposure to a particular share price movement. I hope that's clear. So when you're looking at if you don't include in your portfolio, you go out in the market today, you sell all the shares in the stock market, and then you say your portfolio is zero. Let us say you go out at 9:15, the market will open, you go to the stock market, sell everything, borrow and sell everything, and you say my portfolio is zero. By the end of the day, you will either have a big gain or a big loss. That means there is something happening in your portfolio, right? So over here, when you're looking at A and B, uh, which stock will you select? Well, stock A, because at the same level of risk, I will pick up the stock which gives me the higher return. So I'll pick up stock B. Are we clear with this? At the same level of risk, I will pick up the stock which gives me a higher return. That is why we are saying that stock B will dominate stock A. That is correct. Stock B will dominate stock A. Okay. On the other hand, if there's another situation where you have A and B, both of them give you a 12% return, but A carries a 10% return risk, B carries a 8% risk. Which stock will you select? Will have the same return. At the same return, I will pick up stock which gives me a lower. No, I can see some students mentioning A. How did you get A? Either ways, in either case, see, this is return, this is risk. Given a choice at the same level of risk, I will pick up a stock which gives me a higher return. If both stocks are having the same risk, I'll pick up the stock which gives me a higher return. On the other hand, if both stocks are giving me a same return, I'll pick up the stock which gives me a lower risk, earning the same return by bearing lower risk. So basically stock B. This is the second possibility, and the third possibility is when you have A and B. Let's say A is having a 12% return at a 15% risk. B is having a 15% return at a 10% risk. Again, over here, I will say that B is giving me a higher return. It is having a lower risk. So either ways, I would say I would pick up stock B. It gives me a higher return at a lower risk. Now, these three possibilities are possibilities where one stock, that is B, is dominating stock A. When will this not work if something like this happens? There is A which is having a lower return, but it also has a lower risk. B which is having a higher return, but it also carries a higher risk. For example, in which case you cannot say over here there is no dominating security. I will say that no, B is having a higher return, so B is dominating. Oh, but B is also having a higher risk. In the earlier setups, B had a higher return at the same level of risk, or it had the same return at a lower risk, or it had a higher return at a lower risk. Either ways, B was dominating. In all these three earlier cases, we could say that B dominates A. When does B dominate A? When it generates a higher return at the same risk level, or it generates the same return at a lower risk level, or it generates a higher return at a lower risk. In either of these cases, I would say that B dominates A. However, in this particular case, I cannot come to that conclusion. I cannot say that B dominates A. It does not dominate. So how will I do security selection? We will study a lot of ratios going forward. Coefficient of variation, Sharpe ratio, Trenner ratio, Jensen alpha. A lot of these evaluation measures will be there because B gives you a higher return, but well, it also comes with a higher risk. A gives you a lower return, but it also comes with a lower risk. And hence, you might look at various ratios, various analytical tools to identify the better security considering both risk and return. So over here, if I look at the theory of dominance, it's a very simple question. I would say question number 10. Let us review that once for applying the theory of dominance. Question number 10, page 146. Following is the data regarding 6 securities. Return percentage is given to you and risk percentage is also given to you for these 6 securities. Which of these securities will be selected? Achha, are they asking you the best security? Not necessarily. They are saying which of these securities as a group will be selected. How will you do that? Well, I will look at securities where there seems to be a clear elimination. Like I look at return 1, 2 and 3. Can I see 3 securities, that is A, B and F, have the same level of return? Let us look at the risk. A has 4, B has 5 and F has 6. So can I say A dominates B and F? Given a choice between A, B and F, I will definitely put my money in A because A is giving me the same level of return, that is 8% as compared to B and F, but at a lower risk, that is 4%. As compared to A, ratio of risk is more in B. Yes, that can be used for analysis for that is not dominance. I mean, dominance is a clear, here there is evaluation, there is analysis. Domination means you are clearly out casting one of these. Yes, so currently I'm removing B and F, then we will see anything else having 8, no. So then I look at risk. Within risk, I would say that A has 8 and 4, D has 4 and 4. So both of them have the same level of risk, but then A will give me a higher return. And as a result, D will also be eliminated. So what is left is A, C and E. Now A gives me the lowest risk, but it also has the lowest return. C gives me the highest return, but it also comes with the highest risk, and E is somewhere in the middle. And as a result, securities to be selected will be A, C and D. Now they're not asking me which of them is the best security. Well, if they had asked me, I could have used various ratios which we will evaluate in due course, like a coefficient of variation or a Sharpe ratio or a Trenner ratio, Jensen alpha. We'll study these ratios. But currently, if I have to select multiple securities, A, C and E will remain in my final evaluation. Okay, what next? Assuming perfect correlation. Perfect correlation means correlation number is equal to +1. Perfect positive correlation. Analyze whether it is preferable to invest 75% in security A and 25% in security C. Okay, they are saying that if there is perfect correlation, there is perfect positive correlation, what will happen if I invest 75% in A, 25% in C? Let us try. So let us try to find a portfolio return, that's weighted average. Acha, portfolio risk you can calculate using that big formula. Is there any shortcut possible in this? According to you, any shortcut possible? So when I look at, I think this is question number 10. I will say return of A and C is the weight of A 75 into the return, that is 8, plus weight, that is 25, into the return, that is, I think, what is it? Uh, 12, which means if I multiply, this is what? This is, I think, 6 plus 3, so this comes to 9. Standard deviation AC. Okay, the correlation is 1. So can I use the shortcut? Okay, so this is weight of A into standard deviation of A plus the weight of C into standard deviation of C. If you can recollect that, great. If not, you can even use the longer formula. You will get exactly the same answer. So this is 0.75 into the standard deviation of A, which is 4, plus 0.25 into the standard deviation of C, which is 12. So this is 75 into 4, this is 1, no, sorry, this is 3, and 0.25, this is again, I think, 3. So this is 6. So this portfolio gives me a return of 9%, and the risk of this portfolio is around 6%. Now, they don't just tell me to calculate, they say whether it is preferable to invest in this portfolio. How will you comment on this? Whether it is preferable to invest or not? Well, you'll have to make a comparison. So this is a portfolio of A and C. With what will you compare? Well, there is a remaining security called as E. And if I look at E, E also has the same return, that is 9%, but it comes with a 5% risk. So what do you guys think? Well, I would might as well invest in E rather than investing in a portfolio of A and C, because I can still earn that same 9% return, but at a lower risk, that is 5%. So I would still say that E will dominate. E dominates the portfolio of A and C. E will dominate the portfolio of A and C. Shouldn't we square 6 because the formula is A plus B the whole squared? Well, it is A plus B the whole squared. If you do, you will get portfolio risk. When you square root this, the square goes, and that is why you don't need to square. I mean, if you square it on the left hand side also, you will get the variance. You want the standard deviation, so ultimately you will have to square root. Are we clear with this? Yes. Acha, if you are facing difficulty in this shortcut, forget it, do the longer formula, you will get the same answer. Don't rack your brains too much behind this. Okay. So over here, this takes care of question number 10. Next, you go to question number 9. Let us review question number 9. Suppose Mr. X is in a world where there are only two assets. One is gold and one is stocks. He is interested in investing in his money in one, the other, or both assets. So he is open to investing all the money in one of them, the other entirely, or he is okay even investing in both of them. Consequently, he collects the following data on the returns of the two assets over the last 6 years. So for gold and the equity market, you look at the average return, look at the standard deviation, and there is a correlation. As you can see, the correlation is a -4, minus 0.4. Well, this is given, but practically as well, gold is one of the only assets which has a negative correlation with equity. Otherwise, something like a real estate, bonds, almost all of them, as equity goes up, they also go up. Gold is one of the only assets which in a long run has shown a negative correlation. Yes, in recent times, it is not exactly negative, but generally over a long term. If Mr. X is constrained to pick just one, so not a portfolio, not anything, if he is constrained to pick just one, which one would he choose? Okay, can you tell me which one would they choose? Like, gold seems to have a lower return, equity seems to have a higher return, but gold seems to have a higher standard deviation. Equity seems to have a lower standard deviation. So is there any security which is dominating? That is right, it is equity. Equity dominates gold because it gives you a higher return, that is 20, at a lower risk, that is 22. Perfect. Next, Mr. Y argues that this is wrong. There is a new person coming in the picture, Mr. Y. He says that Mr. X is ignoring the big payoffs that he can get on gold. Today's environment is a classic example of this. If you have seen the markets over the last 1 or 2 years, gold and silver have performed exceptionally well. But if you look at the long term history, let's say over the last 15 or 20 years, there has been no time frame where they have given you such a big payoff. Now, there are multiple reasons why in the last 1 or 2 years they give a big payoff, but that is just the thing that happened over the last 1 or 2 years. Now, when I look at Mr. Y, he says that you are just looking at the average return of gold, which is 8%. However, if you look at the last 1 or 2 years, there is a very big payoff that gold gave. How would Mr. X go about elevating his concerns? So, this is a theory question. You guys tell me, should your decision making be happening based on an average return or based on 1 or 2 outliers? Yes, the decision making should be based on an average return principle and not based on a big payoff that would have come in 1 or 2 years. That was even equity might have given a big payoff in 1 or 2 years. So decision making should not be based on the big payoff that is generated based on 1 or 2 years. It will be based on average return. Like point B, we should always make our investment based on average return and not based on exceptional return in one of the years. Though gold may have given a huge payoff in certain years, that does not represent its consistent earning potential. We should make our investment decisions based on the average return that gold has given in the past. Okay, so this is sub point B, more of a theory point. Now you look at C, how does a portfolio composed of an equal proportion, that is 0.5, 0.5, in gold and stocks do in term of mean and variance? Earlier we'll find variance, but then we'll also calculate standard deviation for an interpretation perspective. So if I look at point C over here, what is happening? Question number 9, point C, if I calculate the return of gold and equity with a 50-50 weight, 0.5 into gold gives you an 8% return, 0.5 into equity gives you a 25% return. So if I do 20% return. So if I do this working, I would get what? I believe 14%. That is my average return. And if I look at the standard deviation of gold and equity, I'll have to use the big formula only. In the big formula, the weight, that is 0.5 squared, into the standard deviation, which is 25, I think, 25 squared plus 0.5 into 22 squared plus 2 into 0.5 into 0.5 into 25 into 22. But this time around, the correlation is a negative 0.4. So this will result in a good risk reduction. The third term will become negative. So if I do this working, this is what, 625 into 0.25. This comes to 156.25. 22 squared into 0.25. This is 121. But when I see the third term, this third term becomes what? 110 negative. So it results in a risk reduction per se, and you get 167.25. If I square root this, it's 12.93 or 94 approximately. Now, this is a very good risk reduction. If I compare the individual risk of gold, it is 25. The individual risk of equity, which is 22, but when I bundle them into a portfolio, the risk actually falls to around 12 point something. And hence, the negative correlation is playing an important role in giving me diversification benefits. So when I look at the point C, I would say 14% and 12.93%. If I want to find a variance, it is the square of the standard deviation, that is around 167.18. But if I want to find a standard deviation, I'll take 12.93. Okay, now point D is a very interesting understanding from a practical standpoint. Mr. X came to know that there is GPEC, which is the cartel of gold producing nations. Like, I don't know, you might have heard about something called as OPEC, oil producing exporting countries, where very recently UAE left OPEC, and there's a lot of things which were happening. Earlier, this was a cartel which was managing the oil prices, but now OPEC has its own set of problems. In a similar way, let's say there is GPEC, it is a cartel of gold producing nations here, is going to vary the amount of gold it produces with the stock prices in the country. So this is production of gold, so this they will control the supply of gold. So economically, demand remaining constant, if the supply changes, the price is going to change. I'll again repeat, what does economics tell you? Economics tell you that price is a function of demand and supply. Now if GPEX says that I will vary the amount of gold that I'm producing in response to the stock prices, that is, I'll produce less gold when the markets are up and more when it slows down. What effect will this have on the portfolio? So let us put it in, let us say, some economic context. Let us say this is your gold price. Currently, demand curve slopes downward, supply curve slopes upward. So this is your gold price which is set up. Now, if GPEX says that I will produce less gold when stock markets are up, so I will produce less gold, so your supply reduces. So my supply reduces, becomes lower, let's say something like this. Then what will happen to the price? Well, the price will go up. Now, this might seem to be a complex economic chart, but if you apply some common sense, in general, if your demand is the same and if the supply reduces, like for example, even products like onions, tomatoes, mangoes, if there's unseasonal rain and let us say the supply falls, the price of those products go up. So what is happening is the price will increase. So over here, if equity markets are up, what they will do is, for gold, they will reduce the supply and therefore gold price will also go up, which means there will be a positive correlation. The current negative correlation will not remain. There will be a positive correlation. On the other hand, what will happen is, let's say again, this is at equilibrium at the center. And now, so this is downward sloping is a demand curve, upward sloping is a supply curve. What will happen is, if and produce more when it slows down. So if they're producing more of gold, supply increases. If supply increases, what will happen to the price? Well, the price will kind of fall. Earlier, your price was higher, supply increases. Again, this is economic chart, but common sense will tell you that as there is more supply, demand remaining constant, the price has to fall. So if equity is falling, what they do is they increase the supply, so gold price will also fall, and hence again there would be a positive correlation. Sir, how is it positive? Both of them are falling. A correlation means they're moving in the same direction. Their co-movement is happening in the same direction, and thereby, if GPEG does what is given in the question, gold, which was earlier giving a good diversification benefit and it was helping me reduce my portfolio risk because of that negative 0.4 correlation, will no longer give me as much diversification benefits. Are we clear with this? It's more of a theory more than calculations. But do you understand that if what GPEG claims will actually happen, then the negative correlation that was historically seen in gold, which was a negative 0.4, will no longer happen. It will move into a positive correlation. No one is saying it will become a positive +1, but it will become positive, and thereby the diversification benefits that you are getting by adding gold into your portfolio will actually reduce. Are we clear with this? Okay, so when I look at this point D, when stock market is up, less gold will be produced by GPEG, which will reduce its supply and thereby increasing its price. Further, when stock market is low, more gold will be produced, thereby increasing its supply and reducing its price. GPEG's decision will cause a positive correlation between gold and the stock market, and hence the diversification benefits arising from investment in equity in gold will not continue. Okay, now this is regarding gold in general, but if you look at economics, that's right, standard deviation will be more. It will not be 12 point something, it will actually be more. There's a big economic debate in general, if you even Google up, on how is the price of gold determined. Like, the value of any asset theoretically is a present value of future cash flows. Now, almost every asset is going to get, like, iron is used somewhere, steel, copper, everything is used, crude oil, it has utility value. Gold is considered to be a store of value. So if gold is approximately 1,50,000 today for 10 grams, how is that derived? Economists, at least, cannot find a theoretical base. They say that, well, it's more of a demand and supply. People are demanding, so the price is changing. But I cannot, like, if you look at the value of a share is the present value of its future dividends. Share gives you dividend. Value of a bond is the present value of its future interest and redemption value. Value of real estate is the present value of the rental yields, etc. But gold, very difficult. It's simplistically, it's a yellow metal that shines, but it is in short supply across the planet, and historically it has been used as money. So gold is still valued, but theoretically, if I remove all that historical bias, to find the value of gold theoretically is very difficult. It is more of a demand supply function. Ke bhai, theek hai, this will be used. Now, people say that it is used as a reserve for currency, which is no. Gold standard has been abolished many decades back. So no one on the planet says that I can only issue as much currency as much as gold I have. No, that has been abolished long time back. So it's a theoretical debate on why the gold price is still so high. It's largely because it is limited in supply, and it is perceived as a safety net, a store of value, and hence uh, is gold overvalued? Well, on a theoretical sense, gold has no value. If suddenly, like there are lab grown diamonds, if suddenly something like this, people are trying that, which is coming, which is going to replicate gold, it does not have any value. I mean, I'm just going off track, but I don't know if you read up online as well. Uh, in the 1800s, in around 200 years back, you know which was the most valuable metal? It was aluminium. When you go to, if you go back 200, 300 years back, and if you go back to Napoleon Bonaparte, the French ruler, if you go back to his, let us say, ruling castle, they would, whichever ministers or guests would come in, let us say, Napoleon's court, would be served in gold and silver. But Napoleon himself or these kings themselves would eat in aluminium, because aluminium was supposed to be very rare. Then in the late 1800s to early 1900s, there were two scientists which could find a way to kind of get aluminium extraction to be a lot more easier. And then aluminium currently is having very low value if you go to see. So it is not even thousands of years old. It is hardly 200 years old. In the late 1800s, aluminium was very valuable, very difficult to extract aluminium. Before that process to extract aluminium was found in a much more efficient way. So kings would eat in aluminium, and the subject would eat probably in gold, silver, or other metals. So I'm not saying that gold does not have value. I'm no one to say that gold has a lot of value, but it does not have a theoretical base other than demand and supply. The fact that it is short supply and it is demanded because people perceive it to be a store of value. If the store of value shifts to something else, like let's say Bitcoin or something else, maybe the gold value can crash. Or if people more believe in the store of value concept, then gold, silver can go up. But it is more speculative and store of value thing rather than a theoretical base. Like crude oil is used, it has utility. Okay. Because of weddings, it is overvalued. Yes. In weddings, I mean, to be honest, ornamentation of gold is more of an Indian. If you go to the Western countries, or if you go to, let's say, China or a Japan or Korea, they don't have so many gold ornaments. So the utility as an ornament is very much an Indian or a South Asian concept. Kind of, yes. But let's say that is my 2 cents, and you can also do a bit of research, and it's a very interesting topic per se. But let's say that is how gold has always carried a lot of value, so it is some time away till the time it kind of changes. But I mean, we always have very short-sightedness on history. We just look at what is happening currently. Even if you go back, zone out a few 100 years back, you see a very different scenario, and you will fast forward, forget 100, 200 years back with AI and everything. Over the next 5-10 years, we are now, I believe you are the first generation, I believe, who does not know how the jobs will eventually shape up in the next 5 to 10 years. Almost always there was certainty that, okay, these are the jobs that we will do. Maybe we want to do better, but these are the jobs that we will definitely do. But here there is so much of turbulence, so much opportunities as well as threats. So it's a very interesting time to be in. Okay, so nevertheless, we'll go into the next section where we discuss this a bit. If there are multiple securities, how do you calculate portfolio risk? How do you calculate portfolio return? Well, if there are more than 2 securities, let's say 3, let's say 4, then you use the formula a plus b plus c the whole squared, or a plus c plus d the whole squared, etc. So if I review the theory and then go on into the questions, what do you want in question 8? It is in question 8, you have the weights. If you have short sold, the weight is negative, and if the weight is negative, you use that negative weight in the same formula. So the only trick you need to remember in question 8 is the fact that the weight of a security that you are short selling is negative, because you get a cash inflow. Other places there is a cash outflow if you were to invest in a stock. And once you take that, everywhere you take the negative weight. Perfect. Okay, so for houses, how is it valued? Typically, I mean, there are various bases, but on a simplistic basis, it will always be looked at the rent that it will get. Like, for example, cities like Bengaluru, there is a big shoot up in the rentals over there, and the value of the house technically will be the present value of the rental yield that it will get. And if it is getting a higher rental yield, the value of the house will also appreciate. Okay, so we'll just review this once. Theory of dominance. This is a theory. Okay, we'll probably come to that again in by the end of the class, because I believe most of you are clear with that short sell concept. So theory of dominance. This is a theory when one security is considered to be superior to the other security based on the relative risk and return. Like a security which is higher return at the same level of risk, lower risk at the same level of return, or a higher return at a lower risk. So these two concepts you saw in question number 10, whereas this was applied in question number 9 between gold and equity. In case a security gives a higher return at a higher level of risk, or a lower return at a lower level of risk, then theory of dominance does not apply. Instead, we'll have to compare risk and return using various techniques like a Sharpe ratio, Tanner ratio, coefficient of variation. All of these will be done at a later point. Okay. Then if there's a 3 security portfolio, portfolio return can be calculated as a weighted average return, which is done in this way, and risk can be calculated as follows. So A squared, B squared, C squared, 2AB, 2AC, 2BC. Well, this is the same as A plus B plus C the whole squared. If there's a 4 security portfolio, again you see A squared plus B squared plus C squared plus D squared, 2AB, 2AC, 2AD, 2BC, 2BD, 2CD, where correlation term is multiplied to each of these co-movement terms. So this is what we have already discussed. And for this, we'll go to question number 13. So let us review question number 13, please, on page number 148. Let us go to question number 13. A portfolio consists of 3 securities, A, B, and C, with the following relevant information. Okay, so you have expected returns A, B, and C. You have the standard deviations given as 33, 28, and 26. The correlation coefficient between A and B, B and C, and A and C is given to you. If the weights of these securities are equal, find out the risk and the expected return of this portfolio. Honestly, this is a plug and play question. If you know the formula, you plug this data in the formula and you'll get the answer. Like, you have to find the weight. Well, weights are equal, so that is 1/3, 1/3, 1/3. And you have to find the risk and return of the portfolio. So if I look at the return of the portfolio ABC will be the weight 1/3 into the return, that is 27, plus 1/3 into the return, which is 24, plus 1/3 into the return, which is 22. So if I were to total this, this is 9 plus 8 plus 7.33. This is 20. So this is around if I multiply each of these, I think the answer over here will be 7, 24, 24.33%. You can just put this over here, 24.33%. Okay, then you are going to look at the portfolio standard deviation, which is again that big formula. And over here, you can actually, there can be a trick where everywhere, if I go to see, this is 1 by 3 squared into 33 squared plus 1 by 3 squared into 28 squared plus 1 by 3 squared into 26 squared plus 2 into 1 by 3 into 1 by 3 into, you'll have 33 into 28, 33 into 28. This is correlation of A and B, so you will pick up 0.2 plus again 2 into 1 by 3 into 1 by 3 into again 33 and 26. This is A and C. So this is 0.5 and 2 into 1 by 3 into 1 by 3 into 28 into 26. Over here, there's a negative 0.4. This is between B and C. So, I mean, you will have to do this manual process. Practically, you will have Excel models where you can just input this data and these models will calculate the answers for you. But that is some time away from in our CA exam. So here what you can do is this 1 by 3 squared is common everywhere. So you can actually take this 1 by 3 squared, even over here in the other terms, 1 by 3 into 1 by 3, 1 by 3 into 1 by 3, 1 by 3 into 1 by 3. So you have 1 by 3 squared common everywhere, and you can do the math and you will get the final answer as around 18.84%. So you'll have 18.84%. That's about a 3 security return. Are we clear with this? Yes. Okay. So this kind of takes care of question number 13 as well. Now there is another formula that we need to use, and there are a lot of formulas in portfolio, but there's another formula that we need to use, which is called as a minimum variance portfolio. Now this is not really important from an exam perspective, so we'll broadly try to understand and remember this formula and apply it wherever it is asked or required. But from an exam perspective, it is not necessarily going to be a very important concept. So if I look at the minimum variance portfolio, what happens in case of a minimum variance portfolio set? So for a minimum variance portfolio, if you have two securities, well, you found portfolio risk, but you can calculate portfolio risk in different weights, permutations and combinations. Like when you did question number 5 today, you found that at one of the places your portfolio standard deviation came to 0, at one of the places it came to 1.26. So that ways there are different weights will give you different portfolio standard deviations. However, there can be portfolio. Can you explain calculator trick to get? So there's no calculator trick per se. I mean, over here you just have to use the memory function properly. Whatever you are multiplying, you put the first term into the memory, second term when you multiply, put it into memory, third term you put into memory, and then do a memory recall. So अब ये थोड़ा personal जा रहा है. My portfolio is not something to be shown. What portfolio? We are also not having as much in the portfolio. So let's focus on getting the minimum variance portfolio. So what do you mean by minimum variance portfolio? It means that if there are two securities, and this is a formula which is the drawback of this formula, it is only applicable for two securities directly. So if there are two securities in a portfolio, then what is that weight where you can get the minimum standard deviation? Can you explain a few extra things using or showing your portfolio? let's focus back. When portfolio में ऐसा honestly there is nothing to show. it is almost similar to your portfolio only, maybe less than your portfolio in size. Okay, so over here, when we look at a minimum variance portfolio, let's say there are two securities, there is A and then there is B. I look at the weight of A. Now, how do I calculate the weight? Just remember this formula. Don't rack your brains too much behind this. This is calculated as standard deviation squared of B. This is important. For the weight of A, you are taking the standard deviation squared of B minus the covariance of AB upon the variance of A plus the variance of B minus 2 times covariance of AB. Are we clear with this? Yes? Okay. So, I mean, the logic for this formula is a little patchy, but this does not really come as much in the exam, so it's not as important. But nevertheless, if I have to discuss this, this is a formula for finding the weight of a security A, which results in the minimum standard deviation possible for your portfolio. So we're not able to understand it as well. So I mean, there's a homework section sum that I want you to possibly try. Just a second. If in your practice book, on page number 32. So there are a couple of questions which I will tell you to try in your practice book. You will try question number 1. You will try question number 2. And question number 3, let's say we'll do later. I'll discuss this maybe tomorrow as well. But question 1 and 2 are basic questions that you want to try, and there is another sum that I'll give you. So these are the 2 or 3 things that you have to do before tomorrow's session. Just a second, I'll just explain that to you. What are we trying to come to? That is what I want you. So over here, see what is happening. Mr. X is presently concerned with an investment of 1 lakh rupees. He has 2 securities, S1 and S2 for this purpose. The relevant information in respect of these 2 securities are as follows. So you have 12% and 20%, 10% and 18%. So this is data given for return as well as SD. SD is the standard deviation. Coefficient of correlation between S1 and S2 is 0.15. He has decided to consider only 5 portfolios of S1 and S2 as follows. All funds in S1, 15 S1, 15 S2, 75 in S1, 25 in S2, 25 in S1, 75 in S2, and all funds invested in S2. So over here, there are 5 possibilities. Find out the expected return, that is a portfolio return in each case. The risk factor associated with this portfolios, that means portfolio risk in each case. Which portfolio is best from the point of view of risk, that is portfolio which gives you the lowest standard deviation, and which is best from the point of view of return. So this is a very easy question and you can definitely try this. Now what I want to communicate through this question is there are 5 possibilities. 100 in S1, 0 in S2, 50-50, 75-25, 25-75, 0 and 100. Do you think there are other possibilities as well? Do you think there are other possibilities as well? Yes, there are other possibilities as well. Now, if I want to find that weight, maybe 61-39, maybe 72-28, which gives me the lowest possible standard deviation, I will have to do a lot of trial and error. I will have to keep on doing, okay, 75-25, then 76-24, then 77-23, and so on. And then I will, through trial and error, come to a number, come to a weight which will give me the lowest standard deviation. Now, instead of doing that trial and error process, I can use this particular formula. And in this formula, the answer that I will get will necessarily give me the lowest possible standard deviation. Like if I look at this particular question, over here, I don't know, there is standard deviation of S1 10, standard deviation of S2 is 18. So if I were to look at the practice question 1, they have not asked me to find the minimum variance portfolio, but I'm using the data in that. So for finding the weight of A, I will take the variance of B. What is the variance of B? 18 is the standard deviation, 18 squared minus the covariance of AB. Now the problem is I don't have the covariance of AB, but I do have the correlation. Acha, can I calculate correlation AB equals covariance AB upon standard deviation A into standard deviation of B? So if I rearrange correlation of AB into standard deviation of A into standard deviation of B, this will give me the covariance AB. So this is 0.15 into 10 into 18. 0.15 into 10 into 18. This comes to what? 10 into 18 into 0.15 comes to around 27. So this will be, let us say, the covariance of AB. So I'll say minus 27 upon, yes, in the denominator, someone is saying you can use A minus B the whole square. Technically, yes. But I would say, let us stick to this number in the formula. This is 10 squared plus 18 squared minus 2 into 27. So over here, if I took 18 squared, this is 324 minus 27 upon 100 plus 324 minus, I believe, 54. So if I do this working, 324 minus 27 comes to 297 and 424 minus 54 comes to 370. So if I do 297 divided by 370, this is around 0.8027, 80.27%. Now this will give me the weight of A. What is the weight of B? Well, you can calculate it directly as 1 minus the weight of A. So if weight of A is 80.27, then the weight of B will be around 19.73. Now, what I give you as a challenge is you try question number 1, find the portfolio standard deviation at each of these 5 possibilities. You can take any possibilities. Then you can use the 80.27 and 19.73 weights if you want to, and find that standard deviation at 80.27 and 19.73. That will give you the lowest possible standard deviation between S1 and S2. So the job of this formula is to give you the lowest possible standard deviation which can be attained by combining S1 and S2. Now, if you have S1, which has a property of 10% standard deviation, S2, which has a property of 18% standard deviation, and there is a co-movement of around 0.15, there will be one combination between these two which will give you the lowest possible standard deviation, and that combination is 80% and around 19 or 20%, and that will give you the lowest possible. So that is the objective of this formula. Are we clear with this? Yes. So when I'm looking at the minimum variance portfolio, first I will review the theory on this. The minimum variance portfolio. When a portfolio consists of this is on page number 40 of your shield. When a portfolio consists of 2 securities, then the combination in which these securities can be held in order to get the minimum portfolio risk can be calculated as follows. Okay, so if your portfolio has 2 securities, then the combination in which these securities can be held in order to get the minimum portfolio risk can be as follows. So this is a formula, weight of X. The most important thing that you need to remember is, for finding the weight of X, you can highlight this if possible. For finding the weight of X, you will take the variance of Y. Everything else is okay. Minus covariance of X, fine. The denominator you have X squared, Y squared, minus 2 times covariance, that is fine. So, this is the most crucial thing. Like, okay, if I wanted to build up, ये तो मैंने shortcut कर दिया for weight of B. If you build up, you guys tell me, when I start with the weight of B, if I wanted to find, not as simplistically 1 minus weight of A, which is possible, but if I had to start, what will I write in the numerator? Variance of what? For finding the weight of B, I'll take variance of what? That is right. I will take the variance of A. Everything else will remain the same. Minus covariance of AB upon variance of A plus variance of B minus 2 times covariance of AB. This is going to entirely remain the same. So if I look at variance of A, for example, this was 10 squared minus 27 upon 10 squared plus 18 squared minus what was it? 2 into 27. So this is 100 minus 27 upon 100 plus 324 minus 54. So this will come to what? 100 minus 27 is what? 73 upon 424 minus 54 is 370. And if I do this, 73 upon 370, there you go. You get exactly the same answer, 0.1973. It is exactly the same answer. I don't need to do all of this because I can find one of them and from that I can easily derive the other one. But this is something that you can definitely apply. Are we clear with this? Yes. Okay. So over here you'll have weight of y, which will be 1 minus the weight of x. Alternatively, for the weight of y, you can take the variance of x. So if you want, you can just note down over here for wx comma take standard deviation y squared and wy take standard deviation x squared into bracket opposite. Are we clear with this? Okay, the above formula gives weights in which the two securities can be held in order to minimize portfolio risk. However, there are drawbacks of this formula. There are two drawbacks. First, it will give you the weights to minimize risk. But what about return? This formula in its working does not take the return at all. It just takes the standard deviation covariance. It's purely a risk formula. So it can be a good starting point. So you can say that, okay, well, you know what, at 80-20, I will have the lowest risk. But does it meet my return goals? If yes, great. If no, I can just keep on shifting from this 80-20 weight till the time I reach my return goals. So it ignores return as one of the big problems, and secondly, it can be applied to a two security portfolio only. So for multiple securities, more than two securities, the formula etc. is beyond the scope of your curriculum. In case there are more than two securities, an efficient frontier is created on which all portfolios, we'll review that in some time, but as of now, what you have to kind of focus on is on a two security portfolio. The logic of this formula, well, I'll just try to explain this in brief, but I've seen students getting more confused rather than getting clarity in this. And because it is not as important, we don't want to delve into it in too much depth. But let us say, if required, I can just try to explain in brief what it is trying to showcase. What I'm trying to do is, I'm trying to find the weight of A when I take the standard deviation squared of B. If you understand, great. Otherwise, don't spend too much time here. Just remember this formula and proceed. Wherever it is required, we go into a lot of depth. Where it is not, it's not really required to create confusion. But nevertheless, if we discuss this, see what I'm trying to do in the numerator is I'm trying to find I've taken in a way the total risk. Over here, what I'm taking is the total risk of B. We understand that out of this total risk, some of the risk is in a way overlapping with A. Co-movement, that risk covariance is overlapping with A. So on a simplistic ground, you can say that this is like the overlapping risk with A. So I say out of the total risk of B, there is some risk which overlaps with A. Let me remove that. And what is remaining is the core individual risk of B. So I'm saying that after removing the overlapping risk that is there with A, what remains is the individual risk of B. Okay, in the denominator, if you go to see, it is the same thing. It is variance of A minus, acha, forget this is written as two covariance. It is basically variance of A minus covariance of AB, and then variance of B minus covariance of AB. So that is why there is two covariance AB. So what I'm doing in this formula, if you want to understand the logic, is I will take the individual risk, core individual risk of B, and divide this by the individual risk of A plus individual risk of B. So relatively, I'm finding that individually B has a lot more risk, 297. Even if there's a total 324 variance, out of which 27 is overlapping with A, I can say remaining 297 is the total individual risk of B. Now, out of the total individual risk of A and B, that is out of 370 ka total individual risk, 297 is attributable to B. So B has a lot more individual risk. So I give more weight to A. I don't want to give more weight to a stock which has more individual risk. I want to give less weight to a stock which has more individual risk. And as a result, I give that weight to A. So if B has more individual risk, I will use that as a base to give that weight to A. If you want to understand, this is the broad rationale. Beyond this, don't go into too much of detailing, but if you understand this broadly, this is what this formula seeks to achieve. If there are two securities, I try to find the individual risk of one of them, then the individual risk of the other of them, and then try to find the kind of proportion. If B has more individual risk, that will be used as a base to give more weight to A, because I don't want a stock with more individual risk to have a more weight. Okay, so if you understand, great. Otherwise, just remember this formula and proceed. That is absolutely fine. Okay, we'll go to question number. So, in your practice questions as well, by the end of the class, I'll tell you what all you need to do. Um, and ensure you do that. Okay, if you do that, that is when you are in speed and you will be able to kind of uh, apply what is done properly. Otherwise, I mean, you will kind of uh, just listen to the lecture. So if you do it on your own as well, it always helps in a better understanding, something that I have not done, so that ways you don't have that bias. So let us go to question number 16. You should be able to solve this easily. P and Q have low positive correlation of 0.5. P and Q have low positive correlation of 0.5. Their respective risk and return is as under R and S. So over here, R stands for, if you want, write down, it's not written. R stands for return. S stands for standard deviation. Okay. Compute the portfolio of P and Q to minimize the risk. So in earlier questions, what was given is you were told compute the portfolio return, compute the portfolio risk. They are saying no. In this question, they are asking you to compute a composition, that is a portfolio, in such a way that it minimizes the risk. So how will I do this? How will I do this working? Well, I will look at the minimum variance portfolio concept and use that. So if I look at question number 16, I will look at the minimum variance portfolio concept. So help me with this. I will start with the weight of P. Well, I want to find the weight of P. I will take the variance of what? Quickly answer. For weight of P, I'll take the variance of what? So I'll take the variance of Q minus the covariance of P and Q upon variance of P plus the variance of Q minus 2 times the covariance of PQ. Now, do I have the variance or the standard deviation of Q? Yes. 25. So this is 25 squared minus the covariance. Now the problem is I don't have the covariance. Can you calculate and tell me the covariance somehow? I will use the correlation formula. So I will say correlation of PQ into variance into standard deviation of P into standard deviation of Q. So this is correlation of PQ, which is 0.5, and you will have 20 and 25. So this is what 20 into 25 into zero point 0.5 comes to 250. So you'll have minus 250. Divide this by 20 squared plus 25 squared minus 2 times 250. So over here this is 625 minus 250 upon 400 plus 625 minus 500. So if I do this working, this is 625 minus 250. This is 375 upon, you will have what? Probably 1025 minus 500, 525. So this comes to 375 by 525, around 71.43%. Now you don't need to again sit and calculate separately. We can always say that the weight of Q will be 1 minus the weight of P. That is 1 minus 0.7143. This will come to 1 minus 0.7143. This is 28.57. 0.2857, or if you show it in percentage, 28.57. Are we clear with this? Now, if the question is not asking you, they're just asking you to compute the portfolio of P and Q to minimize the risk. So at 71.43 weight and 28.457 weight, if you were to calculate the portfolio standard deviation, I can guarantee you that you will get the lowest portfolio standard deviation among all the possibilities. Are we clear with this? Okay. So that takes care of question number 16. Now, before you go to question number 17, question number 17 uses more than two securities, and for that there is a concept of efficient frontier which is not required, or which is not there. We'll review that at a later point. But over here, if you look at question number 17, there are two very basic things that we will use. An investor has two portfolios known to be on the minimum variance set. Like when I look at a simultaneous equation, if there are only two variables, I will exactly know that in two variables, 71 and like in our earlier problem, 71 and around 29 will be the weights. But if there are more than two items in your portfolio, is it possible there can be multiple combinations that can achieve that same lowest standard deviation? Yes, it is very much possible that there can be more than one possibility where you are getting that minimum variance. Like let's say your lowest standard deviation is 10%. Now you are saying that that 10% is achieved by a 71 and 29 portfolio if there are two securities. But if there are more than two securities, if there are three securities, four securities, there can be different weight combinations that can give you the lowest possible. Is that logical at least? Yes. So that set of portfolios which can give you the lowest possible standard deviation can be taken as a base for the minimum variance set. Okay. An investor has two portfolios known to be on the minimum variance set, which means these two portfolios have the lowest standard deviation, which is possible as a combination of these securities. Does that make sense? Okay. For a population of three securities, A, B, and C, having the below mentioned weights. Okay, so portfolio X, 30, 40, 30. Portfolio Y, 20, 50, and 30. Okay. It is supposed that there are no restrictions on short sales. If this sentence is given, it means that your weights can very well be negative. So there is no restriction on short sales. What would be the weight of each of the stocks for a portfolio constructed by investing 5,000 in portfolio X and 3,000 in portfolio Y? Achha, this question is very easy. It is just that when you read it, it is confusing. These words, oh, what is this? So what they are saying in point A is, what would be the weights of individual stocks if you were to invest 5,000 in portfolio X and 3,000 in portfolio Y? Okay, both of these portfolios are on the minimum variance set. I have decided not to put money in all money in one of those portfolios. I said some of the money I will put in portfolio X, some of the money I will put in portfolio Y. So if I put money in portfolio X, you have A, B, and C. A, B, and C. What is the weights of each of these stocks? Well, the weight over here in portfolio X is 0.3, 0.4, and 0.3. Okay, so how much have I decided to invest in portfolio X? Well, I've decided to invest 5,000 in portfolio X. So 5,000 into 0.3, this is 1,500. 5,000 into 0.4, this is 2,000. 5,000 into 0.3, again, this is 1,500. This is portfolio X. Then I've decided to invest 3,000 rupees, can be some other amount as well, in portfolio Y. And what is the weights? 0.2, 0.5, 0.3. 0.2, 0.5, 0.3. So in rupees, this is how much? Well, I've decided to invest 3,000 over here. So 3,000, and this is 600, this is 1,500, and this is 900. Now, what is the question asking me? What would be the weight for each stock for a portfolio constructed by investing 5,000 in X and 3,000 in Y? Well, I will take the total amount invested in rupees. So this is 600 and 1,500. Can I say 2,400 invested in stock A? 1,500 and 2,000. Can I say 3,500 invested in total in stock B? And 900 and 1,500. 2,400 in total invested in stock C. Okay, so this will give me my total out of 8,000. How much is the weight? Well, 30% over here. I believe 2,400 divided by 8,000. Then 3,500 divided by 8,000. This is it correctly calculated? Sure. Seems to be 2,100 आ रहा है यहाँ पे. 1,500 and 600. Sorry, bad maths. सर टाइम हो गया. If time is done, किसी का दिमाग नहीं चलता. 2,100 divided by 8,000. This is, I think, 0.26. 25. 3,500 divided by 8,000. This is 0.43. 75. And last one, 2,400 upon 8,000. This is 0.3. Are we clear with this? Yes, okay. So the question is just asking you something which is very basic. They are saying what would be the weight of each of the stock in a portfolio constructed by investing in 5,000 in X and 3,000 in Y. Now, if I go to see in these portfolios, before I go to the second point, is how much amount is invested in C. If I look at portfolio X, 30%. If I look at portfolio Y, 30%. Which means if I take a combination of X and Y, I put money fully in X, still 30% will be in C. I put money fully in Y, still 30% will be in C. Or if I use some combination, I put 5,000 in, let's say, X, I put 3,000 in Y, still ultimately how much money, how much proportion of your portfolio in this particular case will be in C? Can you tell me that? 30% only? Okay, so this is an important point that will be helpful when you go into the second part of this question. Second part of this question says, suppose the investor invests 4,000 out of 8,000 in security A. So I'm clear, I want to invest 4,000 out of 8,000 security A. How will he allocate the balance between security B and C to ensure that his overall portfolio is on the minimum variance set? Now, the question has to give you some data to help you to calculate this. If your portfolio has to be on the minimum variance set, you will have to either invest all your money in X, or you'll have to invest all your money in Y, or you have to invest some of your money in X and some of your money in Y. But you have been told that you want to invest 4,000 in, let us say, security A. You want to invest 4,000 in A. Now, how much should I invest in B and C so that I continue to remain on the minimum variance set? I don't know. I don't know how much should I invest in B, but do I know, come what may, how much do I have to invest in C? How much? Well, I have to invest 30% in C. And as a result, if you want to remain on the minimum variance set, so if you want to remain on the minimum variance set, I can say for sure that on C you will have to invest 30%. So out of the 8,000, you will have to invest 2,400 necessarily in C. The question has told you that you have to invest 4,000 in A. So that is around 50% in A. And hence the balancing figure, I believe this is 1,600, will have to go in B. So over here, if you have to remain, is everyone clear with this? So if you review the theory, and sir, the question will be, what if they don't tell you this? There's the next sum we'll do tomorrow where this will not be given. So we'll see what is to be done. But otherwise, if the question requires you to calculate weights, it has to give you some hints, or you will have to use some methods in order to calculate. In this case, C has a constant weight and hence you can use that. So over here, a reference note in order to find a minimum variance portfolio for more than two securities. It's not there in the syllabus. However, in case there are more than two securities, there'll be multiple combinations through which minimum variance can be attained, not just a single combination like in the earlier problem. There can be multiple combinations. In order to be on a minimum variance portfolio, we can invest in either of the portfolios, that is either X or Y, or a combination of these portfolios which are on the minimum variance. So in the second point, in this case, 4,000 out of 8,000 is invested in A. The remaining 4,000 will be invested in B and C. In order to be on the minimum variance set, an investor will either invest in X or in Y, or a combination of X and Y. In either case, the weight of security C is going to be 30%. And hence, in order to be on the minimum variance set, investment in C should ideally be 30%, at least in this case. So A is 4,000, C is going to be, let us say, 2,400, and hence the balancing figure, that is 1,600, will go in B. So the balancing figure will go in B. So that ways, that will take care of question number 17. On similar lines, we'll do a question tomorrow where, let's say, the weights are not equal. So we'll see what is to be done, but we'll discuss that tomorrow. And I want you to try before tomorrow's class. I want you to try question 19. You see, this is an LDR question, but there's nothing new over here. Please don't log in without trying this question. I've also given you two homework questions. If you have lesser time, you can do that later. If possible, you finish that. But this question you have to try. Everything that we have done since yesterday's class, all the way till now, is going to be tested here. What do you have? Well, you have a investor who has 1 lakh rupees, wants to invest in shares of two companies, let's say ABC and XYZ. The projections of returns of the two companies along with their probabilities are given. So you have the probabilities. You have 4 returns, some of them positive, some of them negative. You are required to comment on the return and risk of individual securities. So basically you will find ABC bar, XYZ bar, you can call it as A bar and X bar. Then risk and return of these two shares with a portfolio of these shares in equal proportions. So this will be calculating your portfolio return and portfolio risk, and find out the proportions of each of these above shares to formulate a minimum risk portfolio. So here you also use the minimum risk formula. There's zero new things over here, but this is a question that you will use for practice even before your exams, so that in one question you will get everything to practice. And I want you to try this before tomorrow's class, come what may. Homework problems, practice 1 and 2. It is implied in that question that C will have a 30% weight. Okay. So but I want you to, without fail, try question number 9 from the classwork section and 1 and 2 from the practice section. Okay. So I guess that should be it for today's session, and I hope you have got a good insight into portfolio concepts. Tomorrow we will complete this, and we will also go into the capital asset pricing model, CAPM, which includes beta, which is another important area of this syllabus. Okay. So that should be it. Stop for the day, and I'll see you tomorrow. Have a good day. Bye-bye and take care. If you have any doubts or queries, do let me know. Uh, all the revision videos are put on, say, for all the topics, I think over in the last few months or a year or so, all revision videos for AFM are there. So currently, in the next 1 or 2 months, I don't think we would need, but if there's something, I'll definitely add. But otherwise, if all the revision videos which are fully updated and relevant are there currently on the YouTube channel only. Any other doubts or queries? Yes, correlation coefficient and correlation mean the same thing. Okay. I think yes, tomorrow also we'll be doing it on YouTube only. Why did we take CS constant? Because the question had two portfolios on the minimum variance set. You had X and Y, and in both portfolios there was a 30% weight. So if I want to be on the minimum variance portfolio, I will have to invest either in X or in Y or a combination of these two. Either ways, I need to put 30% in C because that 30% remains constant. Can we also take B as constant and take this as a balancing figure? Not in this case, because B's weight is not constant across X and Y. See, if you want to remain on the minimum variance portfolio, you have to have investment in either X, which will require a 30% investment in C, or in Y, which is required a 30% investment in C, or a combination of these two, which will also ultimately require a 30% investment in C. B is not the same case. Chapter wise weightage, I'll just give that to you tomorrow. I think some students would have dropped off already. Short sell, once again, see, in short selling, you are going to, let's say, you don't have money. As an article clerk, for example, you don't have money. Now, if you want to buy a share, you think it goes up, you need money. But you think that if I know that there's a particular share whose value is going to fall, so I want to sell it. So if you want to sell it, you need to have the share with you. You don't have the share with you. So what you go is you go to a broker and you borrow that share. You borrow that share and you sell that share. Once you sell that share, you will get money. You give the share to the exchange. So let's say you sell it at 100 rupees, you get 100 rupees in your account, and your demat account will show a negative. Like if you buy a share, your demat account shows a positive, your demat account over here will show a negative exposure. Then after, let's say, 2 months, the price actually falls, you buy that share back at let's say 80 rupees. So if you buy it at 80, you will pay 80 rupees. You earlier sold at 100, so you got 100 rupees, so 20 rupees became your profit. So short selling is done by people who want to profit from a falling market in a bear market. If nothing is available, you will take the weights of the security short sold as negative. I think whatever are the additional problems in FR, their PDF and their respective videos were required would be shared in your Google Drive. Just a second. Hello. ठीक है. So I guess that should be it. We can stop for the day and we'll continue tomorrow. Have a good day. Bye bye and take care.